Can I have some light on? Yeah, okay. Hello, welcome to this workshop on hydrogen, an initiative of Climate Change Research Institute. We are progressively, as an institute, contributing to the scientific and technological solutions for the emerging challenges posed by climate change. And hydrogen is now one of them. I will just come to it why it is. But I find that post-COVID, this institute, we have taken this initiative to hold this program physically in collaboration with the India International Center and as a physical event with the participation of the experts and youth. But I must say that it is, as we are getting much used to webinars, it is very difficult. It is getting very challenging because there are lots of uncertainties at every stage. So I'm very happy that finally we have landed in having a program. And hydrogen, why it's so important? I think you will, when we go along, you will understand that. And let me start with one of the things that when we think of climate change, then we all know that it is the greenhouse gas emission. Almost it is known to everybody that it is the greenhouse gas emissions which are getting increasing and getting accumulated in the atmosphere. So climate change, global warming and climate change is happening. And by one estimate, it is 40 gigatons of carbon dioxide has been there in the atmosphere in 2021. which is said to be almost double of 1980 value. So the way it is increasing in an accelerated manner is a matter of great concern. And the another point why we are having this program is World Environment Day. All of you would know that in 1972, the first Stockholm, which is always called Stockholm Conference on Environment and Development, was held in 1972 in Sweden. So it is also 50 years in 2022. So 50 years, the Sweden is given the responsibility again to host the World Environment Day after 50 years. And also the theme, Only One Earth, was actually based on the Barbara Ward's book that she wrote on Only One Earth, and we should care our resources and take care of the planet. So that was also published in 72. So this year, the same theme has been repeated, Only One Earth, because of that. So it is actually, his book was named as Only One Earth, Care and Maintenance for a Small Planet. So now, since we are now discussing hydrogen, I must say in the beginning itself that it is a passion for some people. I think Professor Yadav will agree with me. And it is also an opportunity for some other. Ma'am will agree with me. But it is a need for a clean energy transition for a nation. So we have to do something. It is must. And hydrogen, in fact, if you can prepare in lab very easily, but then that doesn't work out when we talk of a hydrogen on that scale, and we are going to invest billions and how many dollars we are spending on this program. So I think the delegates, I welcome, especially you have come all the way to know your future, how you will be able to handle these challenges. So it will in exposure to that. So technologies can be grouped actually, since it is a zero carbon, zero emission gas. So we can think this is the best because if we use this, no emissions will be there. And that is the easiest way to cut down the emissions in the atmosphere, in contrast to the fossil fuels, which are majorly responsible for global warming. So maybe hydrogen can act as a balm for the climate change. And IPCC, especially the report of Intergovernmental Panel Climate Change, says that it is going to be a decisive role. Hydrogen is going to have a decisive role in the future energy systems, according to their latest report. So the technologies can be grouped in 4 categories, which I'm going to talk tomorrow. I'll give you the introduction on my presentation, along with the various initiatives which India has taken. We now feel very honored that Shri R.V. Shahi, former Secretary, Power, is presiding over the session. So before I hand over to him, I will like to share with you a few glimpses of the 3 days workshop so that you know what you are going to, because there may not be any confusion in your minds. We have actually planned to have an inaugural session with the chief guest, Shri Alok Kumarji, Secretary Power, but he could not make it due to his very busy schedule. So we have to miss him. Now, but we have now Ms. Gauri Jauhar, who is with IHS Market and is representing S&P Global in energy transition and clean energy global consulting team. So she will be talking on the mega trends with energy systems, which is quite relevant when you talk of use of hydrogen on that scale. Then we are going to have vote of thanks to be delivered by Shri Gautam Singhji, who is ex-Senior Vice President, Reliance. And we also have a privilege of having Dr. Professor G.D. Sharma here, former Secretary UGC, who will be sharing his concern about hydrogen. And he will be sharing the deliberations, for which we have Professor G.D. Yadav here, Emeritus Professor of Eminence and Padam Shri. From Bombay, he has come all the way to deliver the keynote lecture on the pursuits of net zero goal and sustainability, CO2 refineries and biomass valorization. I'm sure you will enjoy his talk. And then we have another talk from Professor Ghosh from IIT Bombay, but it will be a virtual talk. So that is on green hydrogen economy challenges and opportunities. And with that, we will end the program. Have tea here at about 5 or 5:30. And then we have also today planned a special Environment Day lecture at 6 p.m. by Shri A.K. Jain, former Commissioner of DDA, New Delhi. So he will be talking on climate resilient and low carbon India. And Director Shri K.N. Srivastav of IIC will chair the deliberations. So I would suggest that if you can stay, then it is very good if you can stay for the lecture because it is a public lecture. And now this is the program for today. Then I come to the 9th of June. On 9th, tomorrow, we have two technical sessions. The one is dealing with the hybrid approach of green hydrogen production. Now, hybrid is a very common term these days. You must have said our Prime Minister also uses hybrid many times because if it is more than one type, then it becomes a hybrid. So you cannot these days talk about only physics or chemistry or biology. You have to talk of mixture of methods. So that's why you have to have hybrid technologies using various ways to produce hydrogen. So that is one session. And there is another session on how fossil fuels, which is a hydrocarbon, gets converted into hydrogen efficiently. All fossil fuel is hydrocarbon, carbon and hydrogen. If you can take out hydrogen, it is quite simple. And also why it is so important, because hydrogen is not present in the free form in the atmosphere, in the Earth atmosphere, but it is the most abundant gas of the universe, and it is the lightest gas also. And earlier the program went very slow because it was considered unsafe. So now what we are doing actually is to bring all the energies from universe to Earth. Solar energy first we are trying. Now we are trying to bring hydrogen from universe to Earth to have energy systems. And now we talk of sustainability, but we are getting the things from universe to meet our needs. So we will have lecture on climate policy challenges also. So we have guest speakers from NEERI, CMIFR Dhanbad, IIT Indore, Jamia University, former Vice Chancellor will be there, and former Chairman CERC, Professor V.S. Verma, who is already here, will be chairing the session, and there will be ways of producing hydrogen cost effectively. That is how to convert fossil fuel. And that is very significant part, because at present, most hydrogen is being produced from this gas, natural gas. And we are trying, since we are rich in coal, we are trying to produce it from coal also, if cost effectively. So that is the challenge. A vast panorama of hydrogen production technologies will be discussed, and it is important because we know that hydrogen can be produced in a simple chemical reaction in lab, but that does not satisfy the large scale use we are envisaging. And then on 10th June, the shift is to application side. There are three important sessions. One is about the need for storage to have sustainable hydrogen use, and also for ammonia for their effective use in transport and agriculture sector. It is not yet confirmed, but we hope to have both the discussions. And then a brief discussion on a vital approach for hydrogen using waste. Mr. Rajan Varshney is there. And the most exciting session will be where startups in this sector share their perception to build an ecosystem in hydrogen value chain. And I'm also looking forward to hear to them. It is coordinated also by Mr. Rajan Varshney. So this is the first time being held for hydrogen value chain, to my knowledge, maybe. And various state governments in India are announcing their startup policies, including the Delhi, to build up a strong base. So this will be one of the possibilities, and is listed. The startups are listed in the program, but they may be last-minute additions. So this is in short, we are covering in 3 days. Then we will have certificates for the participating delegates. And with this, I feel honored to invite Shri Sai sir to give his presidential address, who is a well-known and most respected power sector professional in India and also South Asia, with his innovative ideas about power management regulations, and also technologies. So maybe he will be connecting, and you will see by the time we connect. Let me also share that we have prepared a bulletin on lecture notes, which will be shared with you, but we have just few copies today. We'll get more copies tomorrow. And we also seek your pardon if any oversight on our part. Thank you so much for making it possible in a hot weather of June in Delhi. Thank you.
Good afternoon. Are you able to hear me?
Yes, sir.
Good,
Yeah.
good. Yeah, I could listen to you, Maltiji, full speech, because I connected myself right in the beginning when people were still preparing the dais, and then I was disconnected by the organizers to wait for my turn to come. So both video as well as our audio that was muted. So now I am with you. And I must congratulate Maltiji that your institute, the Climate Change Research Institute, which you founded after you left the government, after your assignment, that is doing extremely valuable work in various areas of particularly energy. You were scientists not only for energy, for many areas, but I think your love for power, love for energy, and your interest in these subjects has been huge. For others who may not know, I am there in the India Energy Foundation, and just a minute. Maltiji is the convener of the Renewable Energy Group. We have several verticals. And in India Energy Foundation, in particularly last 14, 15 months, particularly during the COVID period, and even now, we have organized a number of workshops and webinars on energy issues, various energy issues, including on a couple of webinars on specifically hydrogen. Basically, South Asia and particularly India, next to China, we are being viewed as those who are developing now and are contributing carbon emissions to the maximum. China at the highest level, and then following India. Of course, disregarding the fact that others have already done in the past. And therefore, as you all know, that India has been taking a position of differentiated but common responsibility. Of course, Prime Minister has gone a step further in declaring much stiffer, much challenging targets, going beyond what we have been mentioning so far, in trying to say that per capita emission, India is very low, much lower than the global average, much lower than the global average. And therefore, India also needs to develop. So these contradictions between India needs to develop, India needs to grow, India's per capita consumption of power and of other energy items need to increase, then only the fruit of development will be available to large masses of India. Many of us in the intellectual group or higher brackets, you can say, from variety of angles, from a scholastic angle or as also from bureaucratic angles or business angles, we start looking at things from points of view which disregard many of the ground realities of India, rural India. And therefore, developmental needs of India will continue for many years. So we have a job to do. Why India should continue even now at 1200 kilowatt hour. In 1980, India and China were at par, and I am not mentioning about other countries, advanced countries, which have started their development process much earlier in 18th century. And then their per capita carbon emission is much larger. many more times, maybe 5 to 6 times of that of India. So therefore, this challenge for India is there, for policymakers, for our political system, and for that matter, for everybody who is in the society. It is not only left to policymakers and the political systems and governance system to think about this. We have to think it in a balanced manner. Therefore, we have to do both. We can't be irresponsible to the extent of any amount of carbon emission, anything very irresponsibly being done. If technology is available that is not adopted. So therefore, we have to do it in a responsible manner. But that responsibility is of the dual type, as I mentioned, that to handle the challenge of how we should still be trying to minimize the carbon emission and maybe as soon as possible get into net zero. And that net zero target, the Prime Minister, Honorable Prime Minister in COP26 declared at 2070. And by net zero, I clarified in some other program that by net zero does not mean that there will be no carbon emission from any sources of energy or any sources of activities. It only means that if there are neutralizing factors. So neutralizing factors and the adding factors, contributing factors, both together must get to net zero. And that 2070 is the target, the tough target. Honorable Prime Minister also gave very tough and challenging targets for how do we do it, how do we reduce our carbon footprint, and how do we enhance our renewable footprint, particularly on the energy side, energy scene. Energy scene, we are seeing very radical changes that are happening, fast changing. In automobile sector, we're trying to replace our, and having said that, I must also clarify, and most of you know, that it's not only coal. In fact, all fossil fuels are now being put into discussion. Globally, we used to say, with reference to coal, a preferred alternative is liquid fuel, petroleum fuel. And that is why when we were having steam coal engines, we changed the coal engines in our railway system to diesel engines. And diesel became the very important fuel for the country, for economy, for agriculture, for transport, for railways. And therefore, it's not, I mean, that is the gas. Then we said gas will be the fuel, preferred fuel for 21st century. And we have some story. We need not get into details and the availability of gas, the price fluctuations of gas, etc., etc. The criticality of gas-based power stations of not being able to service their investments because the availability is a question mark. So even though it is a more environmentally more benign fuel, still that falls very much in the bracket of fossil fuel. Globally, that is also being put to test. How fast we should get rid of coal or reduce coal, and how fast also following coal we should get rid of these petroleum fuels. For India, that's not the only thing that is thinking of at the global level. For India, it is even much more important to think that 85% of our dependence on petroleum fuel is on import. And that is a very scary challenge. Day in and day out, we know about it. So therefore, big challenges and big disruptions have already started. The pace could differ, but at least the thinking looks to be on that line, and there are more who think that way than those who don't. That should we continue to have our railway system like this? Government has made a massive program of diesel to be replaced by electricity from 16,000 kilometers to maybe 50,000 kilometers of railway systems should be electrified in next few years. That is the massive program that has been made. So that is going in a big way. Automobile going through the electric vehicle, and the things are coming easier to accept that than we thought just 5 years ago. I thought that capital, though operating cost may be less, capital cost will be so high, so prohibitive, whether it be accepted in the Indian market. And that assumption just 5 years ago is proving wrong. I mean, capital cost is also coming down and may come down further. But one of the advantages that India enjoys is that volume, the consumption. Because for any technology to get accepted, any technology to be first tested and proved on prototype and commercial, it is important that it also becomes affordable. Because I have myself dealt with the solar system for long, and the first I came to know way back in maybe around 1985, 86, that California already had it in 60s. In a big way in most of the countries, but the cost still continued to be high. It's only now in the last 6-7 years that you have seen cost coming down, cost of modules and the whole system coming down to 1/5 of what it was just 6-7 years ago. So I think technology development gets accepted and embraced in industry, in society, when it becomes sort of affordable. To some extent, people can put up with the high cost. To some extent, government can continue subsidizing, but it doesn't go further. Thereafter, technology has to prove, and the researchers have to prove its economic viability, commercial viability, and then society at large accepts this, the consumers at large accept this. So now we have gone in a big way. I was mentioning that Prime Minister, all of you know, announced 500,000 megawatt of renewable, mostly solar, and we are going in a big way, in a very accelerated way of developing solar, wind, hybrid. All these things are happening, but it also creates another challenge. What do we do in spite of solar and wind hybrid? We are not able to fully back up the shortfall that gets created when solar radiation is not available in evenings. And mostly in the whole country, the peak of power supply is felt in those hours. And therefore, we have a job to do. So the various options are being today mentioned. Hydrogen is one of them that Ministry of Power, Government of India have announced the hydrogen mission. Good thing is that the large industrial groups have announced very major financial commitments, investment commitments on hydrogen. NTPC has announced, Reliance Industries has announced, Adani have announced, Tata have announced, and many others. Hydrogen is a fuel which is known, I mean, which has been known for decades in various forms, but very small way. Every large factory, even power plant, they have hydrogen plants, so they need it. So the use of hydrogen as a fuel is very well known. And the challenge of handling it is also very well known, because it could cause a lot of problems and accidents, etc. Therefore, the best advantage of hydrogen is that it can be converted into power, in electricity, but it can also be used as a fuel for transport. But then in transport, we have the challenge of the hazard, the safety. So those are the issues which need to be gone into. We did few programs on this, and one such program was focusing on electrolysis as the simplest method of producing hydrogen. And their point was made that to produce 1 unit of electricity from hydrogen, which is produced through electrolysis, you need 2 units of electricity to do that electrolysis. So therefore, the cost of producing that in terms of operating cost itself is high, then investment cost. So I think at this stage, my own knowledge base is limited on the basis of what is being studied, what is being discussed, what is being projected, what is being written, that this has great future, and perhaps it is work in progress. Perhaps it is better placed than battery as a backup. Battery backup we are hearing for some time, because with solar expansion in an exponential manner in Indian context, which is a reality today. You may have 500,000 megawatt by 2030. You may have it by 2032, 33, but that is the direction that our energy sector is going through. Transportation sector is going through. In fact, even agriculture sector is going through. Agriculture is one of the areas where our fossil fuel in the form of diesel is being used largely, and it is being replaced with either solar pumps or solar-driven electricity pumps. So that's going in a big way. So a number of things have already started happening. I wouldn't say they have reached a stage of being critical mass to prove this or prove that, but solar has gone beyond being critical mass, and it has proved itself. And we are now talking, what do we do? Hydro plant, water plant. I mean, hydro means not hydrogen. Hydro projects are again being considered very seriously. The other day I was in the ministry and a very serious thought is being given. Some of the plants which have remained dormant in terms of planning, investigation, etc., etc. As you know that India has 150 gigawatt of potential, and we have done close to about 55 gigawatts. So a little more than 1/3 we have done, and a little less than 2/3 their potential, and all of them may not be workable, but many of them will be workable. So therefore, it will need long-term investments, long-term payback. It will be challenging, but then those challenges have become now very relevant to be handled now, even though a bit costly, even though challenges of construction and commissioning, because solar has to be ensured its continuity in terms of supply as a backup in evenings when solar radiation is not available. And battery is not proved itself so far to be the real economical backup. So you have pump storage, you have hydro plant. We have done 3 programs on nuclear, and I personally believe nuclear has remained in the margin for many, many decades, less than 2% now of the total capacity. And there is a good support. I also support. We invited NTPC. NTPC is very much in favor of going in a big way on nuclear. Nuclear is also carbon-free power availability, power supply. I think, of course, it has a gestation of 6, 7, 8 years, sometimes 10 years, but then that is something, of course, we will have to think that in terms of fuel, we will continue to depend on import in a big way. But then I am told by eminent persons like Dr. Kakodkar that that may not be a big issue, and therefore it could be a good support. And it is in that context, the emergence of hydrogen that has come. I have seen many presentations and listened to many discussions and participated in debates very conclusively in terms of working out that has it reached a level of, it need not be economically viable immediately, but does it have the sort of development which lead us to believe that in next 2, 3, 4 years, it will come in the realm of being acceptable. I mentioned too that solar not new. At least I have dealt with solar for close to 45 years, but only last 5, 6 years it has become economically viable and affordable. So those are the challenges for 2 challenges. One, working it out, whether you produce it from coal. We had a program on coal to hydrogen. Then we had a program on biomass to hydrogen. We had a program on electrolysis, and there were many more methods of producing hydrogen and handling hydrogen. Producing hydrogen with a little bit of support, but with good potential of becoming economically acceptable at a larger scale. And as I said, that India enjoys the advantage of providing a large consumption base. So one of the ways of making a particular technology development affordable is to provide big demands, which is on the higher good side of India's consideration. So those are the issues, and I'm sure the way Maltiji explained, not 1 day, 2 days or 3 days session, and it is basketed into different aspects of examining this issue. I'm sure everybody will be much more informed, because I will not say this is at a nascent stage. It may not be at a nascent stage for scientists like Maltiji or others, and some of the professors and those who have done work on this, but it is definitely at a stage where full understanding of all the issues involved is not available to everybody. Like I may be on a 0 to 100 My understanding of this to maybe 30, 40. Somebody's understanding maybe 70, 80. But seminars like this will disseminate the vast amount of information and data that is available to eminent people like you who are presenting papers and deliberating, which will be available to others. And as I said, challenges are there. Let us see, because options are also there. One is a challenge. Another good thing is this, that you have option of pump storage, you have option of hydrogen, you have option of hybrid of solar and wind, and you have also option of, as I said, atomic nuclear power. So these are the options which are trying to back up the massive expansion of solar energy, solar power in India. And I'm sure hydrogen will have its rightful place in the scheme of things and in the energy profile of the country. I wish all the deliberations all the best, and I thank Malti to have invited me to listen to her, and maybe I will listen to one of you also. Well, after that, I have to go. Thank you very much. Thanks a lot. Thank you. Hello.
Okay, thank you so much, sir, for giving us the insights about the national view on the hydrogen and how it is going. Definitely, it is going very fast and accelerated mode. Few months ago, even we were not realizing it's going to be so important, but suddenly we find that there is a lot of change, and that perception we get from your lecture, and also we have very inspiring talk. Thank you so much, and hope we can think about how to go about it and solve this problem. Maybe finally we get the fusion energy of sun on earth, and finally we forget all these things. But it never be a one energy solution, has to be multi-energy solution for the time being. And if there are any questions, you can raise it now. On the you have the mic on your table. Anybody wants to ask something? Yes. Yes, please. Yes, Dr. E.S. Verma.
Hello. Hello, sir.
Verma
Are you able
ji,
to, Ji, are you able to hear me? Yes. Okay.
Mr. Verma is a most active member of India Energy Forum.
Yes,
And he brings with him a lot of experience in Central Electricity Authority, in Bureau of Energy Efficiency, in Regulatory Commission. And I had the privilege of having him in some of the task forces to solve the problem of electricity distribution in a particular state. So, and then there is hardly any webinar which he misses, and always makes very sensible and very meaningful comments and suggestions. Thanks, Verma ji. Bataiye.
Good. Thank you, sir.
I am not in Delhi, so I have to
know.
participate. But you know, Malti has been an active, not only active member in our forum. I knew her when she was in the Department of Science and Technology, and we were launching this CSLF. That means Carbon Sequestration and Leadership Forum in the United States. And she was an active member there also. I suggested her name to be in the research group, research study group, and she was there. So I have known her from, I think, 2004 or something like that, 2004 or 5. So
Yeah,
long association.
I've learned a lot, sir.
Yeah. Okay, Verma ji, आप बताएं.
Sir, you touched upon three issues. I find it is very important. One is the pump storage. So as I discussed in that conference also, IEF, that if the pump is driven by the renewable power only, then it becomes a green pump storage, and it can serve as the backup for the renewable energy when the sun is not available. But we should try that all pump storage schemes get charged from the renewable energy only. This is number one issue, sir. Number two, about hydrogen, the main issue is bringing down the cost of generation of hydrogen. You also said that 1 unit generated from hydrogen, it needs 2 units of electricity. So at the moment, the indications are that the 1 kg of hydrogen is produced from about $5 to $10 per kg. And unless we bring this cost to around $1, as the Niti Aayog's assessment, till such time it cannot be a commercially viable technology for us. And we have to work hard that the cost becomes low and it must be commercially viable. Any technology which is based on implementation with subsidy cannot sustain for long. Subsidy can be there for initial some period, but ultimately one has to get rid of the subsidy and it must sustain of its own, and the prices have to come down. Similarly, for the electrification, sir, the transport electrification, the Niti Aayog has given indication that we will electrify the two-wheelers and three-wheelers, but on four-wheelers, still the country is going slow because of there are manufacturers in the country. They would not like, they would not switch on to the hydrogen or any other fuel so quickly. I think Niti Aayog has given, as I read in some paper, that they are moving slow on four-wheelers, and we have to think it. And you kindly remember, sir, on one of the things we said that if it is a long drive, maybe we go on hydrogen. If it is an intercity type of transport system, we may electrify and use the batteries, etc. for that. These issues were coming to my mind. I thought I should bring it to your knowledge and to your information, so that I want a little bit of reaction from your side on these issues.
No, I think we have ourselves have been associated with some study which has been recently done for a couple of pump storage systems in Andhra Pradesh. And I agree with you that if we have to have high cost power to raise the level of water in the storage and then deliver that power, then that becomes somewhat difficult to handle. See, there are two views on that. One is that if you compare it with the backup of battery, which is prohibitive. So it's like, how do you make a line smaller, draw a bigger line? So the bigger line is battery. So as compared to battery, everything will get justified. But I entirely agree with you that why not? If we are going to have such a vast capacity of solar, during daytime, you raise the level of water through solar power, which will be costing you 2 rupees or 2 rupees 50 paise. Then even though the other thing is on the higher side, you cannot just you can justify that. So I think preferred option will be what you suggested. That will be the preferred option. And it is workable. So I think pump storage, but pump storage should be done. That will be a good backup for the solar system in evening. Of course, cost of hydrogen, I made that point, but I have seen articles where people have claimed that with a little bit of more work, the cost can come down to $1. So that is at least being talked. So one has a ray of hope. We need not be disappointed. But the point that I made during my presentation to you, that India provides a large consumption base. I remember I had just joined the ministry in 2002, and I had a discussion with people who produce a CFL and were likely to do LED, and they were having prohibitive prices. I said that I will create an order of the order of 3 million, 4 million, 5 million. And same thing I was repeated in LED, and you saw how the prices dropped down. And similarly, the solar modules prices have come down, one because of technological advancements, and another because of the massive size of the orders which have been placed, which have been implemented in China and India and other countries. So I think that advantage India, and also this issue is not only hydrogen is not an issue relevant only to India, it is equally relevant to China and other countries, which are also going on solar in a big way. So therefore, large consumption base will accelerate the demand, and large volume of demand will also bring down the prices. One hopes it should be like this. Transport, I think when we converted some of the vehicles to a large number of vehicles to CNG, you have petrol, diesel, and CNG. So therefore, these optional fuels will be available, and depending on the nature of usage, depending on the volume of that sector, you will see all will have its market. Hydrogen will have its market, electric vehicle will have its market. And it is good for the people that there are several options. The people will see the capex, capital cost, people will see the operating cost. They will also see the sort of safety angle, and finally they will settle somewhere. And therefore, those who are on the technology development side will have to fill up the gaps and remedy the shortcomings and deficiencies that are there. But I would see that next 10 years, we will see all these will prevail and compete with each other, and depending upon the nature of usages, they will be adopted. Thank you. These were 3 points. These are my views. We can discuss again sometime later. Thanks a lot.
Thank you, sir. Thank you so much for giving time and for your valuable time and really inspiring address. We are really grateful to you.
Thank you.
So
I take leave from all of you. Thanks a lot.
Thank you, sir. I now invite Ms. Gauri Johar to give her address, presentation on mega trends in energy systems in times to come. You want to hear or?
Okay, thanks. Thank you so much, Dr. Malti Goyal and Mr. Gautam Sen for inviting me here. It's a real privilege to be here amongst people who think, and research. I think, I think what represents here is people who have been in the industry, who have brought expertise over the years, but I think more importantly, who have the space to think and to really understand how these fuels that we're talking about, whether in hybrid approaches like Dr. Goyal mentioned, or fuels and energy sources that have been known for so many years. I mean, this is really, people who are part of the brain trust of this country to see how can things be commercialized, who've proven it probably at the lab scale, but what will it take to scale it up? What will it take for, we were talking earlier to the gentleman from NTPC, Mr. Rajan, that how can these things be scaled up? How can these startups with new ideas, new innovations really scale up? So I here represent S&P Global, and my colleague Abhishek Kumar, who's our principal consultant, is also here with me. So that's really good. He's been doing a lot of work on hydrogen as well, trying to understand the landscape of technology, policies, financing mechanisms. And what we as a group do is we do consulting in this space. So we're as much thinking with the industry, trying to see what is happening at academia. And really, I think the one aspect which I sometimes feel actually we miss out is this whole academia industry interface. And that's one of the reasons I was really keen to come here, because I feel, we just keep going from one project to another, which a client tells us to do. And I'm not sure we have the space sometimes to absorb fully what developments are happening in this research space. And I think that is the opportunity here for which both of us are here today. And really, again, thanks to Mr. Sen and Dr. Goyal for having us here. As an, sort of a overarching view to this discussion on hydrogen, what I thought could be helpful is understanding what are these mega trends in the energy transition? Why are we even here? And I feel that these mega trends in the energy transition are at the intersection of policies, technology, company strategies, and finance. And that is really the ecosystem we're in. And in this ecosystem is academia, industry, think tanks, technology players, innovators, and very worrying political and supply chain trends as well. Some which come out of, for instance, the post-pandemic recovery we're underway, but some which come also because of war-related disruptions in supply chains. And I think, one of the things before I even get into the presentation is that, we talked about, Mr. Shahi talked about this fall in prices that the world has experienced in solar and the boom of solar as a result. And I think today we're at a point where those, I actually wonder, have we run the course on some of those cost reductions? I mean, now we're talking about inflation, we're talking about interest rate hikes. In situations where cost of capital was anyways higher and it was difficult to raise money, have we run the course on some of the gains we've actually shown in solar, and would those actually come in the way of the progress of some of the new technologies we are trying to talk, whether in hybrid or in solo modes of deployment? So with that background, I don't mean to sound all doom and gloom, but I think that's the reality we're in. Sorry. Okay. So energy transitions are not something new. I think energy transitions have been around forever. In fact, there's a date which our Vice Chairman, Dr. Daniel Yergin, has put. The late 18th century was when we really start. I think he said 1789 is when the first in energy transition really started, when the transition was from wood to coal, coal to oil, oil to gas, and gas to now these new fuels, renewables, and hydrogen and carbon gas, new this thing. So energy transition is not new. The trigger for the energy transition is different this time. And the trigger in the past used to be higher efficiency fuels, different uses. But the trigger this time is the heating of the Earth's atmosphere. And to limit the growth, the heating to 1.5 degrees centigrade rise from pre-industrial levels. So the pressure is really from the climate end to find solutions to deliver better and more sustainable energy. What is interesting is that I think there is a new player this time compared to other energy transitions in the past, which is the financial sector is becoming the front end or the faster end of policy making and policy push that is coming to act on companies, because they are tightening the screws on how you can raise money. And what we've seen come out around COP26 last year in Glasgow was almost these 7 groupings of net zero alliances that came from the financial sector. There was the Glasgow Alliance, the Bankers Alliance, the Asset Managers Alliance, the Asset Owners Alliance, the Investment Companies Alliance. And what you see is that these, if you put all the assets under management they have assets under management which is multiple times the size of the global economy. So you're talking about, just one grouping having, $100 trillion of assets under management. There could be overlaps, but that's where the pressure is acting on. And it came out in 2 forms. It has come out in 2 forms. There is in 2015, when the Paris Climate Agreement happened, the first task force on climate disclosures, TCFD, on financial disclosures was adopted. It was voluntary, but what we're seeing is more companies want to come clean and say, I'm adopting the task force on climate disclosures. This year, the second, I think, impetus has come in the form of the SEC rules, which came out on March 21st this year. And they have provided a framework. Right now, they're in the process of stakeholder consultation. And once those rules come in, within about another 1 or 3 years, we're also that in India, SEBI has come out with the BSRS rules, which have to be adopted by the top 1,000 companies by market cap. When all these financial pressures on Disclosure Act, there has to be changes in business model. There has to be changes in the way companies operate. And those you will typically hear is through the medium of reductions targeted reductions of scope 1, scope 2, and scope 3. Scope 1 being your direct emissions, scope 2 being emissions, again, in the realm of direct emissions, but more related to, for instance, energy use, etc. And scope 3 being more supply chain emissions, emissions that you are potentially impacting, but you cannot fully control. So the way this whole climate trigger of the energy transition is being played out is through the mechanism of net zero goals, pledges, and laws that have been enacted at the country level and are being adopted by companies as well. So when we look at the country level, the last year was a watershed year because the three of the top global emitters in the world, China, India, and US, came out with their net zero targets. And the world was waiting to see what are these three countries wanting to do. And of course, the timing varies, and for good reason. There are a few countries in Northwest Europe, in Northeast Asia, South Korea, Taiwan, who have also made their net zero policies into laws. So that's a handful of countries right now, but pressure could also grow. So about 90% of global greenhouse gas emissions, I think what Dr. Goyal mentioned, 40 gigatons, is now being covered under net zero policies, pledges, laws, varying mix of those. And the other way we see this, when you look at energy transition and net zero, the net zero world, which we are addressing now, the transmission of this world is through I call it a three-legged stool, which is got policy on one end, technology on the other, and financing mechanisms on the third. Because that together, when these three elements come together, that's when you have a financially viable solution. And at S&P Global, we are a leading company which actually has now started putting out energy transition price assessments. So we have energy transition price assessments for a host of different activities, which include carbon capture, which include hydrogen. So we have our new hydrogen price assessments, which are right now cost-based, but most of our price assessments are trade-based. So whenever there's a trade that happens, we make a determination of what that price underlying that trade is. And two of our main variables here are the carbon energy credits, which are being exchanged, for instance, eligible by airlines. That means whenever you're taking whenever airlines are running their operations and people are flying, there are certain carbon credits that get exchanged to offset the emissions coming out of that travel. So it's called CORSIA, because that's managed by the International Aviation Body. And so these are CORSIA eligible carbon credits that we track as carbon price assessments. So that is one curve you see there. The other curve is nature-based solutions. So whenever you see activity which is happening to offset carbon in a natural way, planting trees, etc., that is when we have nature-based credits. And nature-based credits also, there are about 7 different accounting systems in the world on this voluntary carbon market. These are all things under the voluntary carbon market. And we track those and understand what is the underlying price for those trades that are happening. These happen daily. So this is like you track the oil price. This is another price now to be tracked. So I think that's going to be the change. We always know what's the oil price today. Do we know what the carbon price is today? I think that's where we all have to evolve as thinkers that, we always worry, today oil is $120. What's the carbon price? And I think that's where energy transition has a very different flavor in different countries. I always say in India, we still worry about the oil price. I think Europe is worrying about the carbon price today. If you ask, I think a typical European energy economist, they will know the carbon price because it's affecting their business mechanisms. It's not affecting us yet. We are not adopting a carbon market mechanism yet. But having said that, today only the Bureau of Energy Efficiency is taking bids for the national carbon market, to build a national carbon market in India, which will incorporate these mechanisms. And actually, we're also participating in it. But that's just to give a flavor of one of the mechanisms through which energy transition will happen, one of the signaling mechanisms of a market, because ultimately these have to become into markets. Going back now to that three-legged stool, I talked about policy and pricing is technology. So one aspect of that three-legged stool is there's a whole array of technologies which will help us either decarbonize or at least get to a lower carbon level, will help address net zero. Because again, as Mr. Shahi said, net zero doesn't mean no emissions. It means emissions will be offset by the right mix of technologies. And of course, carbon offset mechanisms, carbon credit mechanisms. So when we cast all the developments in the world globally, what we see is that the spend on renewable storage and green hydrogen, which is coming together as investment themes, as technology themes, will be about $440 billion per annum up to 2050. And when you add up all those investments globally, it comes to about $12.8 trillion. That's significant because when you go back to the financial end, which we started with the Glasgow Net Zero Alliance and other net zero financial alliances, all those bankers who are making policies which are going to impact us now, just if you take two of the world's largest asset managers, BlackRock and Vanguard, their assets under management are almost in the range of the spend which is going to go into renewable storage and green hydrogen. So that's the scale of investments we are talking about here. If we go to the next slide. In the suite of technologies, in the bouquet of technologies, as we're here to discuss about hydrogen over the next 2.5 days, hydrogen is becoming integral to the global 2050 vision, because when we run the numbers, we realize that net zero will not be met by renewables. Net zero will only be met by material impacts related to hydrogen and carbon capture. The only way we hit net zero targets is through these two material technologies. And what is great about hydrogen, as was pointed out earlier also, is that it is a fuel which is known. The industry knows it. Carbon capture is a mechanism that is known. It has been known for the last 40, 45 years. I know people who've done their PhD in carbon capture, but 30 years back. So the thing is that these are known, but now they have to be operationalized based on renewable sources of generation. They have to be operationalized and commercialized based on also use cases which are beyond refineries and power plants as in the past. They have to be now brought out of those refineries and brought out of those power plants, put into the transport mix. Also, I think what's interesting is that energy importers like India and China are looking at it as tools for self-sufficiency, energy self-sufficiency, because India is looking at becoming also a green, in time, in about 10, 15 years, a green hydrogen export hub as well. So there is, all this discussion, which is part of the National Hydrogen Mission. How can we build those export hubs? How are they related to the location of those, new electrolysis units, which could be coming up near port units to enable green hydrogen and ammonia export? The second material technology is carbon capture. And I think the discussion on hydrogen is a little more evolved than the discussion on carbon capture, because carbon capture right now is a very US and somewhat China and Australia phenomenon. So when we see these are really the whole slate of projects globally, and all the orange bars are projects which are in early stages of development. So what we're seeing is that more than 60% of global CCUS project states are only in early stages of development, and only about 15% are related to storage. Most of the use cases are related to commercial use cases right now are related to enhanced oil recovery based carbon capture. And there is a problem there. The US has really showcased this use of CO2 for EOR, but if you talk to a banker today, those people who are, the faster end of policy, they have a huge problem. They're like, you're telling me that you want carbon capture money from us for enhancing oil recovery. There's a problem. There's a fundamental problem there. So I think the energy industry has to wake up to this. And I think we're still tying ourselves saying, okay, I can put a CO2 pipeline to enhance my oil recovery based on, gases that can come out of a power plant. It's not going to work in the future because as the financial industry just doesn't understand that use case. They think that again, the energy industry has nearly greenwashed again. So I think that's something to be aware, that use cases have to be beyond EOR. So far, the CCUS use cases that have been prevalent in the US and also a lot of the tax incentives have been largely related to EOR use cases. So the industry has to go beyond that. And the last mega trend here, the second last, is how is this low carbon capex coming on the company end of things? So we've talked about technologies, financing. How is it coming on the technology on the company end? So, you know, in the past, when we used to look at the international energy companies, who are the bellwethers of the industry, because where they go, the rest of the industry follows. Small players, national oil companies, etc. Is that all these different colors in that mix are different low carbon decarbonization technologies, and you see a huge mix here. Just as you used to see in conventional energy sources, you know, someone was an onshore player, someone was a deep water player, someone was into power. Here, what we see is that, for instance, ExxonMobil, being from the US, is more focused on CCUS as a technology. If you see some of the European players, there's a real distinction between the European players and the US large energy companies. European players like Repsol, BP, Eni, they're more on the renewable energy end. Also, if you see Chevron has a large footprint in California. It's at the cutting edge of biofuel resources and recycling. So it's interesting to study these differences. What you see right now, the orange bars are a little less, because I think the energy companies are still determining how they will grow their footprints in the hydrogen energy mix. So I think that will change fast. If we see the same slide, maybe 2 years later, it would have changed. The orange would certainly have grown. And the last megatrend here is about, again, coming back to the financing end, that how does this fast-moving end policy happen actually? It's because of green bonds. So the green bond market today is about $1 trillion, which has just happened in the last few years, actually. And what was interesting again about last year as a watershed year was that energy firms were the largest component of green bonds. And when you see green bond rules, which have been put out by the Climate Bonds Initiative, what you see is that for every funding use cases, they say that now, if supposing a project has to be funded, it has to have at least 80% or 100% carbon capture, recycling, bioenergy use. It has to have an offset mechanism. If it doesn't have an offset mechanism, things will not get funded. And the reason companies are going towards this route is because it offers them an advantage on lower interest rates. So it's lower interest rates, it's green financing, it helps the cost of capital. And I think that becomes even more important when we look at the macro environment of high inflation and high interest rates. So companies will have a funding problem if they do not adopt credible green technology options, as opposed to what, you know, a lot of activists accuse the energy industry for is greenwashing. So on that, I'll hand it back to Dr. Goel.
Yeah.
Thanks.
Probably you stay for some time for question answer.
Sure.
So I think very insightful presentation about the transition which is actually going to take place. And any questions from the audience? Yeah.
Thank you.
Take your name.
I'm Saloni Gupta. I'm doing PhD in low carbon pathways to urban trade from School of Planning and Architecture, Delhi. My question to you is, if we talk about hydrogen fuel buses, bus fleets and four-wheelers, I'm not even getting into the freight market as of now. If we compare UK and India, UK has about close to 300 bus fleet at present, moving on hydrogen fuel, and we are in the phase of piloting and conceiving this. So, which is like 50 new fleet buses that are coming in Delhi. So, my question to you is, what kind of innovative financial mechanisms would you say are, I mean, what is the difference, I mean, in the financial system if we talk about India? And if we talk about electric vehicles also, the banking system in India is such that people are, I mean, they don't get enough financing, even if they want to get into these kind of situations. So the infiltration is very less. So what kind of financial mechanism would you suggest that we go for?
Sure. So I think on the financial mechanisms, the banks, for instance, if you look at State Bank of India, they have their own, end of green bond financing, for instance. They've been doing green bonds. So I think there is an appreciation in the banking sector, in SEBI, that with these new BSRS rules, financing also has to evolve. What I think is also important is to understand, like 27 Indian states have a new EV policy that comes with some level of tax support, some level of tax rebates. So I think, and again in India, it's not like there's an average answer to this question. I think it depends on which state you're in. What dispensation can the charging source, for instance, get for the electricity which is coming into EV. So there are different electricity schedules for EV use as well. So I think it has to be seen as in totality in which state you're in. What are the tax rebates being offered there? What's the state EV policy? And because that could really vary between different states, even the charges, electrical charges, etc. I think on the financing side, I think you have a very good point that it still has to evolve. I mean, you're not seeing like special interest rate schemes that have come out yet. So I think that's something which the banking sector should begin to think of, that if they can look at car financing or two-wheeler financing, three-wheeler financing, giving a special rate discount for that. Now again, all this becomes more challenging in a like the RBI today only increased the repo rate, right? This is the second repo rate hike in like a short time, in 2 months. But you're right. I mean, I think that's something the consumer end needs to wake up to.
Because from what I understand, it's close to about 22% if you want to buy an EV.
Right.
Close to 11 or 12%.
Yeah.
For an ICE.
So EV, the cost is higher, the initial cost is higher, and the point is that over time you can recover the cost.
Then the question comes,
Mhm.
how do we ease the infiltration of hydrogen vehicles? Because if you compare the TOC, total cost of ownership of ICE, and then of hydrogen fuel vehicles, it's about close to 2.5%, 2.5 times more.
Right.
So are we ready to, India as a nation is the nation ready for this kind of inflation of hydrogen fuels financially? I mean, we need
So
to have some
it is early days. I think and again, one has to think of these things in an ecosystem way, that, there has to be much more education to the banks, right? Like, are enough people, are enough of the technology providers, are enough of people like Indian Oil or say Mahindra Motors or Tata Motors, are they talking to their, the ICICIs and HDFCs of the world to connect the dots, right? I think the problem here is that the ecosystem has still to come together. And in the middle of that, we still have a safety issue. I mean, we've been having safety issues with EVs as well. My colleague here is also looking to hydrogen. I don't know if you'd like to offer some comments.
Well,
Yes, actually, I think you made a very valid point that hydrogen vehicles are 2.5 times more expensive than I'm sure that electric vehicles was 1.5 times right now. So if we look at 5 years, right, electric vehicles was at least 4 times more expensive. But what I really think, the entire experience of electric vehicles schemes that is we have to raise bonds, we have to raise two, and all of these things really help the consumer, adopt these new technologies. Plus on top of that, even right now, TV in the consumer segment is really being adopted by, these big operators. It's not us who are doing that, it's really the big operators. And this is all being governed by this is all in labor. There are mechanisms to allow people to adopt. Right. So just like electric vehicles, and very frankly, that hydrogen vehicles are not that good right now, but as soon as they are developed, I mean, currently in the world, we only have two hydrogen vehicles. One is so, as they start to be developed, I'm sure the government will come up with some incentives, something very similar to Spain. On the long term future. Because this is something the government itself wants to target. They want to want efficient and they will do anything to it. Right. So I think we may see something like training from a side, Especially when advanced
Yeah, please. Yeah. Right. Right.
So this is there, but awareness is not.
Mhm.
So what is awareness creation? For example, we were given one demo vehicle to very much one color bottle has a small something more.
Mhm.
And many more are lining up to like
Financing, yeah. Mhm. Mhm.
Sir, please use the mic in case.
Yes, yes, yes. Right, right. Regulate, yeah, yeah.
No, but I have a question. Like you said, green bonds is mainly for maximum for energy. Now, what else it is? Is it
So
energy
there are
efficiency or what?
No, I mean, you can use green bond mechanism for any sector, and energy companies have been tapping it increasingly.
Say, for example, any sector means?
So if there's a certain project you have, say you have a biofuels project,
No, but that is energy.
yeah, but you can finance it through the green bond market. Because
No, other than energy.
sorry,
Other than energy.
other than energy, I mean, for all sectors in the economy, you can use green bond frameworks because it means that you are doing it in a more green and more efficient way. It's a
No, but
direct
ultimately it will come to energy only.
right, right, right.
Yeah.
Yes, you're right. Yeah.
Yeah.
Yeah, yeah. But I'm talking about energy companies tapping the market for green bonds. For their operations,
Okay.
earlier they were not.
And another question was about carbon capture.
Yeah.
Which you said is going to have mega role in transition.
Yes.
So how do you explain that? This will continue or
Yeah. So, I mean, I think the role of carbon capture is under the category of negative emission technologies. So whether you look at nature-based solutions or you look at things like direct air capture, they come under the category of negative emission. That means you can go negative on those emissions. You can just absorb them out. Right now, the only challenge is that those are on the higher end of the cost curve. So that means you're looking at about in terms of dollar per ton, which is a global industry, it's like the oil price. So you're looking at something like $240 a ton. When your carbon price in, say, the European markets are like about $80 a ton. And in India, I mean, I think the closest we've ever come to a pseudo carbon price has been the coal cess in the past. And that was like $3 a ton. So that's the variation. So right now, the commercial end of carbon capture is about $45–50 a ton. And these technologies which have to yet be commercialized, are more like $200 to $240 a ton range. So that's the delta which has to be commercialized. And also, I think one thing in carbon capture that's happening is there's a lot of discussion of hubs. That can we form hubs of sources of carbon? So can there be like industrial hubs, industrial clusters where the carbon can be captured? Because otherwise, isolated cement plant is not enough to be captured in terms of richness of CO2. And then can it be linked in terms of closeness to sinks? And those sinks could be saline aquifers, could be depleted gas fields, or if negative emission technologies can come. Yeah. Right. Right.
so any other question, Dr. Mende? Yes.
Finance.
Dr. Mende has come from Dhanbad. I just wanted to introduce you. Please go on. Please continue. So,
Yeah, this is on, right? Basically, apart from electrolyzer, where the costs are still high, and a lot of research are going on to reduce the cost of electrolyzer, a new technology has come that is using sunlight directly on water to produce hydrogen. It's called synthetic photosynthesis, a kind of thing. It's called photocatalytic, synthetic catalyst. Those technology, that kind of research work is being done in Berkeley. If these things really come up in a bigger way, then probably the cost will come down. But another forecast is that probably China is heading, and amongst all the countries in the world, and they are probably coming down to the cost of, I think, if I remember correctly, by 2050 or so, to $0.65, not even one, less than one. So that's the kind of work that is going on in the market right now. Thank you.
So, thank you. Thank you, Gauraji. We had a very interesting discussion. And now I request Mr. Gautam Sen to present the vote of thanks. And then we have a break for tea and then come back.
Good evening. We had two very interesting.
Please switch it on, please. Yeah.
Yeah, we had two very interesting sessions. The first one by Mr. Sahay. As you all know, Mr. Sahay is a legend in power. Mr. Verma is here, and the two together probably are, they have done what is called the entire electrification of India. I was reading somewhere his biography today, Mr. Sahy's biography. I think he has done you know much more than what I know. He's done a phenomenal work. So he has talked about what are the things that are happening today in today's world, and how, for instance, things like our committee COPO, which we have done, our biggest problem at what he said very correctly is that, look, our per capita emission is still very low. Our development, we still have a long way to go. But the world has already gone to an extent where the carbon concentration in the atmosphere will nearly come to an end of it, because we're already at 420 parts per million. And temperatures, even the most optimists now believe that 1.5 degree would be difficult. So he referred to all those issues, and he says how we can go about it. And he says, we still, in India, the problem therefore is how do you go into carbon, negative carbon? And as Gauri, in fact, later clarified, the only way to do it is, we still have depend on coal, because the only fuel which we have in India is coal, nothing else. Oil and gas is hardly there. So therefore, we have to depend on coal. Now, when we use coal, we have carbon emissions. How do you go about it? So carbon sequestration, or maybe hydrogen, which is now coming up in a big way, can be the solution to get into that net zero emission. So Mr. Sai talked about all these issues. He talked about the various methods of production. He talked about electrolysis. He talked about the prices, the costs, and all that. One thing we must remember is there's a concept called energy return on energy invested. How much energy you put in and how much energy you get out of it. Now, energy return on energy invested in hydrogen is always pretty sad. You put in much more energy, but you get out much less. Primary reason is, like say, water. Water is there. Now, when you're trying to extract it, put in energy over there. So every time you do that, every time you have this kind of situation, so it's a negative thing. But then it's a question of a holistic picture. Do you want the climates to really affect you, or the environment affect you, or not? So in that respect, probably that's why the government and every other government is now moving towards hydrogen. So that's what he talked about. An emergence of hydrogen he's talked about. And then he talked about solar. Solar has come in a big way now, and solar has come. But the issue is with solar is, can we have solar can we replace our fossil fuel by solar? The answer is no. Because if we talk about the batteries, he did mention about the batteries. The batteries, you can't have a heavy vehicle truck driven by solar. We can't have it, because that battery would need continuous charging. So therefore, the only solution is you have to move out of it. Only for light vehicle cars and all that, maybe the solar-driven fuel cells can work. So the lithium-ion battery which you talk about. Then Gauri came up with new ideas. She talked about mega trends, which she talked about 8 mega trends. And she talked about what I like maximum, what her talk is, how she said is 3 things that come up in picture. One is called the policies, the technology, and the finance. The three things have to work together. And how carbon market has come up in Europe, but it has not yet come up in India. So we still have to go in, follow that. She said policy, technology, and finance. The three words she used for it. And that is how things can get into. And the only way she said about net zero is that we have to get into carbon capture and storage. One of the best ways of storage, I think, is basalts. And India has a huge potential for basalts all over India. So that's what she mentioned. And then I think, and she talked about the investments and how different companies are investing, the total amount of investments, how different companies are investing in what different ways, and how there's still a picture different. Like say, for instance, Europe is much more focused in renewables and hydrogen compared to other parts. So that's what is happening. And the other thing which she possibly mentioned was, didn't really touch upon, but then I think it's very important, is how the geopolitics is going to change once the new fuels is coming. The transition, which we are going through a transition, and because of this transition, now we move away from fossil fuels, the importance of probably Saudi Arabia will come down. That's good. But China's importance will go up. Things like that will happen. So we got to live with that. And I would like to thank her for giving time and coming from busy schedule. And of course, thanks to Professor Dr. Sai for spending with us. And the maximum thank goes to Dr. Goyal. She does everything. I was telling somebody today that, look, the whole this thing, getting people, getting all that, getting organization, everything, though we are part of the organization.
You are part of the organization.
Entire story, everything is done by her. And full credit goes to her. We are amazed at the kind of energy she has. And even yes, we actually she's the source. Yeah, absolutely right, Verma. She has got the maximum energy. I don't know how she got it. I guess it. Hydrogen energy. Yeah, she is behind all this, and she gets us to work whatever she little work, but everything she does plans it out herself. And wonderful, I think. And thank you all delegates. Thank IIC for accepting and hosting. Thank you all over here, Mr. Dr. Goyal's team over here, and all the delegates who are attending here, as well as through virtual listening, and all those people, Mr. Vashne, who has taken a lot of interest in getting things done, and through NTPC. I remember that. We had a lot of discussion on that. Thank you, Professor. Thank you very much for coming over here and spending time. Thank you all.
Okay, sir. I have a question. Myself, Pranara Sharma, I am doing BSc Computer Science from Motilal Nehru College. So, as I have seen your credentials, including Reliance and ONGC, so I want to ask a question about oil lobbies, basically, having industry in this kind of technology, because they don't really going to have any sort of interest in hydrogen economy becoming the future. And we have already seen the cases of many companies like Gulf and Saudi Aramco basically suppressing all these kind of technologies and innovations, because a lot of $1 trillion money is included in this thing. So what is your take on this issue?
You're asking me a very basic question. I spent all my life in oil and gas. And today I'm talking about away from oil and gas. So that's what he's asking. My take is this. ONGC started a thing called ONGC Energy Center. Companies, believe it or not, young men, are wedded to one thing called money. Whatever gives them money, they go for it. So if oil and gas give them money, they went for it. Of course, ONGC is a government company, but I'm talking about even the other companies like the Reliance and all that. They are wedded to money. So what gives them money, they go for it. Like say, for instance, Adani. Adani has invested heavily in coal and heavily in hydrogen. Now you tell me, what policies do they have? The policies get money. So that's how the world is driven. So let's not have any ideology, frankly speaking.
But so for next 100 years, we have sustainable amount of oil. So oil companies are never going to shift to another kind of source, basically.
I'll answer that. We did not give up Stone Age because stones got finished. That's the answer. So oil will be there, but if you want to save yourself, look, we are going to live here for another 5-10 years. We are old now. You guys have to live here for 30-40 years. Your children will live for another 30-40 years. The world has to be alive, be what it is for the Homo sapiens. You have to make this transition. In fact, we're already late, if you ask me. We should have done it much earlier. Our generation has spoiled this world. Not us, maybe them, maybe the Western countries.
But so we have known hydrogen since ages. Like solar energy is there since 1950s. And from 7th, 8th class, I have known that hydrogen has the most potential, like in calorific value, it's 1,50,000 around. And I have means since 7th or 8th class, but still we are very lagging behind in this technology.
Okay, I'll answer that.
So,
I'll answer that.
The issue is that the oil lobbyist is in this area actually.
Yeah, I can answer those questions.
Point is debatable. Reason being that you are still focused on oil. The fact of matter is, I'll talk to you about the solar energy, what China is likely to be next 10 years when it comes to alternative, and what technology is changing in terms of doing things. There are two dimensions which I'll just say. So don't get stuck up to one. It's non-renewable source. Today you find it is 100 years, maybe less than 100 years, or you may not need it in course of time. Because technology is changing very fast. Did you know that from 10 years back you had one person talking and not traveling all along and everything. And the augmented reality comes and then you find everything is changing. So let's debate on this.
लेकिन शॉर्ट में वो गल्फ कंट्रीज को भी पता है कि अभी तक वो ऑयल इकोनॉमी में नहीं तो चल रहे थे, नहीं चल पाएंगे. They are absolutely investing
In these things, they are changing.
So they know everything, and you will have to import hydrogen from them again.
Yeah, right.
If you are not vigilant enough to develop your
But that's the selectivity issue, na? That only a few countries are gonna have access to that kind of hydrogen economy.
Can I add a point? So I think it's a very fundamental question asked, and I go back to this, that word hybrid, which I think Dr. Goel also mentioned earlier, that it's about how can hybrid approaches work. It's not about either or. I mean, this room is probably being powered by coal, oil, gas, maybe. And it will continue to be, there may be a solar panel. There could be hybrid uses. I think one of the best uses of hybrid I've seen is that a lot of Indian oil petrol pumps have been solarized. Okay, so those are the types of things which cut your scope on emissions. I think at rigs, right? So, fuel cells are being used. So it's about how can offshore wind come together with a rig, for instance, right? Platforms. So it's not about, at $120 oil prices, absolutely, energy companies will go full hog on producing the last drop of oil. But it will fund the energy transition now. It will not only go back as, buybacks of shares. It will not only go back as dividends. It will fund low carbon capex. I think that's the difference.
The reason is basically climate change. Climate change has driven this transition. Nothing else, not finance, nothing. Finance-wise, fossil fuels are the cheapest. But yeah, I think that.
I think you should wait for my lecture. I will answer all those questions. That is one of the reasons I'm not saying anything.
Thank you very much. We are waiting for tea now, though we planned it at later, but now I think we are losing the energy, but my energy comes from all of you. And I thank my co-organizers, Mr. Sen and Mr. Rajan Vashne, who have been also done a lot about planning of this workshop and the way it has come up. So I am very thankful to you for having come and have part in this deliberations. And it is actually, it's transition, we talk and everything, but it is the process which continues, that what also was mentioned, that how the energy fuel is changing from coal to oil and to gas, and how hydrogen is becoming so important. So hydrogen has been there in 8th class, you're right.
Yeah.
But then now it's so much new dimensions have come that you can't think of it really. I didn't know a few months back, to be frank. I'm telling you. So I've been only getting to know when to do this work. So thank you all, and let's have a break for tea and come back soon. We start at about 4:25. 15 minutes break, sir.
पहला slide लगाए तो actually लोग people will think that I'm You should bring the bhajiyas inside. They will make it. That is what is holding them back. Hello. Those who are interested in my lecture should come inside. Otherwise, you will not be allowed to ask any questions. Yeah. Yeah, I will start. Yes, Madam Dr. Goyal. It's not coming?
I think, let me take the position.
Yeah, I think, yeah.
Let us start, I think.
Yeah, I think you have to start it, right?
No, yeah.
Beside all.
Well, friends, we begin the next technical session. Professor G.D. Yadav is with us from Institute of Chemical Technology, which is very well known in the country and world, because I know that in Bombay University, I was a product of Bombay University, and M. Shana was working very seriously on the subject chemical technology, and it was given advanced center status and other things. One of the very important aspects of chemical technology, which is taking advantage in many other countries of the how do we store the solar energy, which is taking place in many other countries. I'll not go into, I'll talk to you, I'll talk later, but to begin with, let me tell you briefly that we moved from animal and human source of energy long back. That was the source, and it was going on. When they say India was on pinnacle of growth, development, it was human and animal source of energy. It was an energy which was tiring, so one could not go beyond. But at the same time, development took place because of human and sources. Major breakthrough came with the mechanical sources of energy. That was with the steam, fire, and this thing. From their electricity, from their fuel, and from the later on we went to nuclear also and solar also. Solar has been also there for almost 30-40 years also. Now we are going on to hydrogen. There are several sources of energy. There is a cost for a production of every unit of energy, and then there is also usability, flexibility of the systems, etc. All involved. I'll come to speak on the solar little later, because what kind of experiments are going on two sides. One is on solar energy absorption, storage, and communication. And on the other side, the AI is goal and quantum computing goal, which is coming in a big way in next 10 years. And one of the projections which are saying that what's going to happen after 2041. 2041, which I'll share you a little later. But let me give a chance and request Professor G.D. Yadav, who has come all along from Bombay, to share his idea, or he's doing a project on hydrogen net electricity generation. I'm not much aware of hydrogen. Other areas, that's why I like to listen from you and see what kind of. As an economist, I know what kind of energy role has been played in the world and in India and many other parts. It's going to play in future also, because all development process and other development models are linked with that kind of thing. So let us listen from Dr. Yadav.
Thank you. I think you were in Mumbai University as a faculty member.
Yes, long back.
Yes, and you moved to UGC. So anyway, you are my colleague then in that case. Thank you so much. Ladies and gentlemen, I'm going to talk on a very exciting subject, and some of these guys who asked the questions, I will try to answer those questions, including the cost of hydrogen production. And I must tell you, because I have a meeting with the secretary, petroleum secretary at 6 o'clock, so I must finish my lecture much before that. I hope this works. Hello? Is it on? No? No, it is okay. Is it? Oh, okay, now it. Yeah, you don't have battery there or what? All right, can you give me the next slide? Yeah. Next slide होता है क्या? Even the manual thing is not working. Yeah, no, but let me. No, I can say many things. Okay. Well, anyway, everybody knows. Is it working? Are you doing manually or it is working on the remote? What is that?
I think you have not taken Teams.
Okay, anyway, so everybody knows about Paris Agreement and what happened in 2015. 195 nations signed the agreement except United States. And Donald Trump was dead against it. Next slide, please. And then what happens during the presidential election campaign, Joe Biden promised that he will go for net zero. And so there was a huge hue and cry there. Arey Baba, go to the next. Okay. One slide back. Is it working? Yep. Okay. Oh, okay, sorry. So, last year, April, he organized this Leaders Summit on Climate. Our Honorable Prime Minister had also participated in that. And that is the time they said, yes, we reiterate that by 2050, we should have net zero. Okay, that was the statement. So, see, since 1750 to 2018, where the data were presented, billions and billions tons of carbon dioxide has been emitted. And as Madam was saying, 40 giga tons of carbon dioxide was emitted in 2021. So before that, it was, 35 gigatons. So we stand at number 7 in this list. US, China, Russia, Germany, UK, Japan, and India. But our population is so huge that we are going to overtake it if our energy needs increase. Okay. So in the 26, India committed for net zero by 2070. My question is, why not 2070? Because it is a political decision. Government wants to be on safer side. But my personal belief, I may not be allowed that time. Some of you may not be there. We will achieve it much before that. India will achieve this much before that. That's my personal belief, because technology advances like anything. And we should not underestimate our scientists and engineers. Okay, this is my personal belief. So this is CO2 concentrations. In 2020, in January, it was 410 ppm. Within a year, although there was slowdown in economic activity, we added 2 ppm. That time, the refinery used to process something like 97.4 million barrels per day. Okay, that was the capacity. And we went down to something like 85, and on 10th of April 2020, we had a negative price of barrel. And now we are talking of 120. And the negative means we produce more and there was no storage. Okay, that was a problem. And now it is 420.69 ppm. So we are adding, supposing we are adding 10 ppm every year, you can imagine what is going to happen. As per this, chart, which is IPCC, if there is not enough technological intervention on carbon, 20 to 50, our carbon dioxide emissions will be something like 2000 ppm. That will be the end of the world, I'm telling you. All this, because every city will be under water. So to achieve 1.5 degrees C, which some of the experts believe that it is not going to happen if we don't have technological intervention. And this is where hydrogen plays a very, very important role. So let me give you some ideas about it. Next. Okay. So, since I'm a chemical engineer, I must also tell you, look at this particular slide. Can you show any 3 man-made materials or products without the use of chemicals? Whatever is there in front of you, on your body, everywhere. If you show 3 of them, you will get 100 million pounds. Okay, 100 million pounds, which is waiting since 2008. Scratch your head and come up with some idea. It's not possible. Nothing is possible. So chemical and allied industry, in which I will add these refineries also, play a very important role in our daily life. And why? Because it is a carbon-based economy. So what do we do about it? Okay, that is the next question. And at the same time, we are generating so much of waste. In 2025, one person will be generated about 1.6 kg per day. So an 8 billion population will be there by that time. So imagine how much waste will be generated. So tomorrow's world will not be just chemical engineering, biological engineering, chemistry, whatever. It will be recycle engineering. Can we recycle materials and energy in some form, some other form? And this is where the new technology, including the hydrogen, will come into picture. So the sustainable development, which is SDG 17 goals, number 1 and number 2 are very important for entire world. That is, no poverty by 2030 and no hunger by 2030. That means we have to use all sorts of means, including genetically modified food, where people don't accept it right now, because our tillable land is going down day by day, right? Our population is increasing. And the climate change is there. So 2 degrees, you can imagine you have to develop new variety of crops and seeds and cereals, which will, tolerate this temperature rise. Then only it is going to, so it is science and technology alone which is going to help us. And the SDG 9 says industry, infrastructure, okay, and industry, infrastructure, and innovation. So unless we are innovative, it is not going to happen. There are many others in that, okay? I won't go into the details, but so this is what it is. Recycle engineering, whether it is physical, chemical, or biological, we will recycle everything. And this is where new technologies will come into picture. Batteries, for instance, batteries have second life, but not many people know that we can have recycled batteries. We have lithium, and we are talking about lithium-ion battery. You are holding that in your pocket. And if we don't do that, we will require 3 Earths. And we have only 1 Earth. That's what you said in the beginning, right? We have only 1 Earth. So what are we going to do about this? So, the West, you see, 1.6 billion tons of CO2 equivalent greenhouse gases were emitted in 2016, which about 5% of the global emissions. And in 2050, it will be 2.38 billion tons of CO2 equivalent per year if no improvements are made in the sector, energy sector, and carbon. So carbon is very, very responsible for all this business, okay? So this I mentioned to you that, for example, battery recyclability is one of the important areas. And right now it is China and United States, they are leading. China is leading this sector, and India should not lag behind. We must have a policy by the government on recycling. We just talk about 3R, but we are not doing anything. And that is related to sustainability and climate change, and your organization is climate change. So battery recycle, we call it battery recyclability. Not only that, you see how much business is there in that. Huge business is there. Okay, battery recycling business. So if you want to have a new company, think on recyclability. Okay, young man, you were talking about something, I'm giving an idea. Okay. So remember, what is going to happen? There will be 8% CAGR market growth rate for this. Battery recycling business alone, it will have so much of growth. Okay. And if you go further, so we can go on talking about battery recyclability, different types of technologies and new batteries. Now, for example, manganese-based batteries are coming up. Sodium-ion battery is there. And Reliance is very much interested in vanadium, because vanadium can be used, and every ton of crude oil gets a lot of vanadium. So vanadium-based batteries could be talked about, because vanadium is poisonous, so people are worried. But it is a cheap source of making batteries. So why are we not doing that? We have to think on those kind of things, okay? And so energy, environment, and climate change are intimately connected. We want more energy, we are going to do more damage to the environment because we want to use carbon-based materials. One of the things I'm going to talk a little later about is plastic and the plastic ban. Foolish idea, I'm telling you that. Ban never works anywhere. It is recyclability, some other form, whether plastic upcycling, recycling, downcycling. The cost is always associated with segregation and sorting. So there are means of doing it. Okay, I'll tell you that, how we do that. So for me, we talk about Brahma, Vishnu, Mahesh. That is how Hindus, Christians say, God, Son, and Holy Spirit. That is their Trinity. I'm sure they borrowed it from India. But the new Trinity for me is solar energy, wind energy, and hydrogen. And I give hydrogen topmost priority, because hydrogen alone will give us both energy and materials and chemicals and whatnot. Solar and wind is not going to give us. Even solar will require some polymers, and that will come from these materials only. Wind also will require. So hydrogen is the topmost in all this. So government of India should have hydrogen-based economy. That is what. So all policies we have to redefine, reinvent, and promote research and innovation in this area. They are just having money somewhere stored in Petroleum Ministry on hydrogen. So let us look at some of these ideas. Okay, so this policy by Ministry of Power on February 17, they had a notification. That is green hydrogen and green ammonia. Very good. And by 2030, we want to have 50% of that. So great movement. Perhaps you know that Germany already has this green ammonia policy as an energy carrier, because ammonia can be split. It can be used in IC engines. It can be used in fuel cells. And what you get water and nitrogen, which is a part of. So water and air will be our feedstock for everything. From water, we will get hydrogen and oxygen, and both hydrogen and oxygen are required for conversion of biomass or valorization of biomass into fuels, chemicals, and materials. So it's not a new idea, but that is what is going to happen. So look at the hydrogen, what it can do, where we can use it. Once you have hydrogen, you can produce energy, you can put it in the grid. Okay, you may have fuel cells, hydrogen-based fuel cells. So you will have 2-wheelers, 3-wheelers, 4-wheelers, okay, which can be used on hydrogen. Okay, you have carbon dioxide, which is there in the atmosphere. Carbon dioxide refineries, we can convert that into methane, ethane, higher hydrocarbons, petrol and diesel. All those can be made, and I'm doing work in that area. So I've been supported by ONG, so I must thank them right now. And then we have upgradation of when you do pyrolysis of biomass, including waste material. We don't have to have, anything other than that. We can convert the bio oil, again, it has to be hydrogenated. So hydrogen becomes important. Then only the value will be increased. Okay, green ammonia. So hydrogen coming from water, nitrogen coming from air, that will be green ammonia. Metal industry is highly polluting. Steel industry produces the maximum pollution. 1 ton of steel produces 2.3 ton of carbon dioxide. So we have to work on that. So I can make green steel by using hydrogen. So hydrogen first plant should be set up next to the steel plant. Unfortunately, our ministries are different. Power ministry is different, petroleum ministry is different, steel ministry is different. They don't talk to each other. That is a problem. Okay. And then we have all these chemicals and allied industry. We use hydrogen in tons and tons. We are familiar with that. Hydrogen we use everywhere. And then you have heat and electricity, which American or cold countries, they have to heat their homes. 33% of energy used for housing industry. People always blame the transport industry, but housing industry consumes a lot of energy. So yes, what it means, hydrogen will be the savior of the world. Mark my words, hydrogen will be the savior of the world, nothing else. Okay, so, oh, hydrogen, why are you stopping there? Yeah, okay. So we have supply chain of green ammonia and green hydrogen. So in this hydrogen business, somebody said you spend more money on producing hydrogen. I can tell you that I have done a process where I can gain energy out of that hydrogen, whether you have wind power, solar power, hydropower, whatever you may have an electrolyzer or thermochemical process, produce hydrogen, produce ammonia, and then you go to a variety of these industries, including power generation, fuel cells and whatnot. Okay, so that is the beauty of this hydrogen and ammonia policy. Okay, so now the ammonia which we get, because ammonia is required for fertilizer industry, and ammonia was the greatest invention of 20th century by the chemical and allied industry, Haber-Bosch process. He got a Nobel Prize for that. So, but now that was coming from CO2, because supposing you take coal and make hydrogen, or take natural gas and make hydrogen, that is a gray hydrogen. It has a co-product of carbon dioxide. So carbon dioxide-free ammonia will come from water only. So water should be the feedstock. Okay. So carbon-based fuels and hydrogen. So whatever carbon-based fuels you have, because that is what gave us this luxury, comfort, long life, whatever. Remember, in the year 1900, the average age of Indian male was 38 years. Female was 43 years. Today, what it is? 68 and 73. Ladies always live longer. You should clap hands for yourself. Ladies always live longer because their genetic makeup is different from man's makeup. Genetically, it is proven. Yeah. So what it means, this longevity is brought to us because of this chemical and allied industry. Okay. So that is a major sector to contribute to the GDP. So sometimes some foolish fellows say that ban chemical industry. They don't know. I said, if you ban chemical, remove all your clothes and go home. Because everything you are wearing is a produce of chemical industry. The telephone, mobile phone, which you are using, 20 different chemicals are used there, silicon, and the gallium arsenide, the polymers and whatnot, everything is a chemical. Human body is the best example of chemicals. Okay, so we have to be little careful when we talk about, and so I have deliberately showed this. You don't go into the structure. So our supply for this, getting this high, biomass, there are several biomass, different types of biomass, which can be used for chemicals and materials, including hydrogen. Waste plastic can also be used for making hydrogen. Okay, but people always blame plastic. You know what was plastic? Plastic was a solution to paper because paper used to denude forests. So it was a replacement. But because it is free, you are throwing it. So I was called by government Maharashtra for giving some advice. They said, we are going to ban this single use. I said, foolish idea. I'm telling you why ban never works. Because people will have clandestine means of using it, like the states where there is a prohibition, maximum liquor is sold there. That is a known fact. Senji, you will agree with me. The reason is that when ban means, so even plastic ban, people go and raid the shops and find them. So people are happy to have that ban because they can make more money. Ban doesn't work. So even in the case of plastic, if we say that segregation is done at home, like a newspaper boy comes to your home, and boy comes to your home and the housewife sells the raddi nicely, right? He gets money. So if the plastic boy comes and collects the boy and then it is sold and you have a deposit on that. Supposing the PET bottle, 1 rupee deposit.
I was advising the Sana, Yemen, and one of the requirements that because it was littered with plastic, One of the suggestions which I told to them about 5 years back, that I saw all the pages littered with the plastic. As newspaper you are collecting, let it be collected, recycling, it will have better road system, but
No.
that's a kind of a thing. Recycling becomes very important.
No. At home, there another boy comes and collects that polythene bag. Because it is free, you are throwing it. If you had given the deposit, listen to you. The collection is what at home itself you have a segregation. 80% of the money of the municipal solid waste is on segregation. Okay. So anyway, let us talk. So no matter what is the source of carbon, it is the carbon dioxide. Whether it is a biorefinery or chemical refinery, carbon dioxide has to be tackled. That is why I call carbon dioxide is not a liability, but now asset to us to make chemicals in fuels. Okay, so I will tell you how we do it. So the another question is, should biomass be used wasted for making low value, high volume, biofuels like ethanol? Because that is a pet theme of everybody, right? Because it is a net zero thing, right? It is carbon neutral. But as an engineer, I will tell you it's a bad idea. Because no carbon should be used on energy. It should be either solar and wind. Carbon should be used only for making chemicals and materials. So even if you make bioethanol, convert that into ethylene and variety of products. You will get more money out of that. That is what I'm trying to tell you. And I will show the slide also. So hydrogen right now is used in refineries in 8 different processes. Okay. And where are they getting it from? The steam reforming of methane, natural gas. And that creates carbon dioxide as a co-product, and that is responsible for these emissions. So if you go 100 million barrels per day, you can imagine how much carbon dioxide is being generated by that. And same is the case with biomass. Biomass, hydrogen and oxygen, both valorize biomass. So all these processes, whatever we use, these 8 processes, hydrogen is required. Suppose I use green hydrogen, even for the remaining oil which is there, I will save the earth from this, carbon emissions. Okay. So remember, this is, in 2020, we had 35 gigatons of carbon dioxide being emitted. And if you want to go down and bring the temperature to 1.5 degrees, it should not be more than 10 gigatons. That means 25 gigatons of carbon dioxide equivalent should be by, renewable energy. Let it be solar, let it be wind, let it be hydrogen. Okay, that is what I'm trying to tell you. So you see, by 2050, we'll have only 2 types of hydrogens. That is blue hydrogen and the green hydrogen. Okay. So specific energy, this boy was telling about specific energy. See that hydrogen has the highest specific energy. So that is the reason. So specific energy, therefore, hydrogen is better than the wood which is burnt in the many households in India. Okay, it is better than. So hydrogen product technology, that is what I'm going to tell you, why hydrogen production technology are important. So we have green hydrogen, blue hydrogen, and gray hydrogen. Green hydrogen, either electrolysis or thermochemical processes, like what we have been doing in ICT. Or blue hydrogen, you may have any steam reforming of any biomass, but carbon dioxide to be sequestered, stored, captured, and utilized. And gray hydrogen, it just goes into the atmosphere. That is what the refineries are doing right now. And sometimes you have 5 different shades, depending on whether it is coal or oil. So you have green, blue, turquoise, where you have a methane as a source, and you create hydrogen and carbon. Okay. So that is another way. But remember, the next side is very important, and that is what it is. That remember the cost. The brown hydrogen based on coal, it is $1 to $2.1. So refineries have $2 per kg hydrogen right now. That is the cost. Gray hydrogen, it is about it. Blue hydrogen with carbon sequestration, it also says about $3. And the green hydrogen, anywhere between $3 to $7.5 per kg. That is what the cost is. So interestingly, the processes which I work, this we call as ICT Mumbai OEC. ONGC Energy Center has been supporting me since 2006. This cost is 95 cents per kg. And I have not added the credit of oxygen, because 1 kg of oxygen is 10 cents. So I get 80 cents. So even if, but the minimum capacity of hydrogen production has to be 100 tons per day. Okay, so we did a lot of these calculations on this issue. What is happening? Okay, so this is ICT OEC copper chlorine thermochemical cycle. Okay, this is we had this particular thing. So since I've been working since 2007 January, right now, so we came to a stage where, because of this COVID, there was a setback, and now they have told us that we will start producing it in Goa, in the ONGC's property. But the ministry says that we should do it on a refinery, and that is why I'm going to meet the secretary. So they like what we have been doing. And I showed through calculations. You can see that this is the number of this. So why this particular thermochemical cycle? Because it is not dependent on electricity. Although it is one of the processes there is, but it is not dependent on electricity. So, and electricity is the major cost. So this gives a nutshell. Professor Sharma, look at that slide. We take solar power, we have molten salt, we have developed different combinations. So we store this energy in that. And then we have a copper chlorine cycle with water being given there, and I produce hydrogen and oxygen. So I can oxygenate biomass, I can hydrogenate biomass, including waste biomass. I can hydrogenate carbon dioxide to make all this methane on all hydrocarbons, and see how many things I produce. I make hydrocarbons, I make methanol, I make dimethyl ether, formic acid, all sorts of ferments, green ammonia, green steel, name it, hydrogen. And very interestingly, now I have sold my technology for dimethyl ether to Godavari Biorefinery, because they are producing 2,000 tons of hydrogen, carbon dioxide in their fermenters. They have a biorefinery. So they have given me money, and we are developing it. We have to sell this technology. And dimethyl ether is a substitute for diesel and LPG. And our catalyst doesn't decay. The catalyst for carbon dioxide to hydrocarbons, 2,000 hours, not a single drop in efficiency. So we have patents. On this hydrogen production, I have several patents. First patent I got in USA, then Germany, then Japan, then UK, Korea, of course India. All these and which is very interesting. So on this copper chlorine cycle, we mastered the art of this, okay, making hydrogen. And so I say it is less than $1. I'm confident. Since 2015, I've been saying it, but I was a loner. People did not believe me. Sometimes people don't believe good scientists in our country. They think somebody else should give that technology. That's a problem. We want to import technology, but we don't trust our own scientists. That is a problem. That is a problem with our country because we think that the outsiders are smarter than us. They are not. My students were given much higher postdoctoral fellowship because they were working on this. I got them written. I told ONGC, it will be foolish on your part if you lose them. So they're still working with me. They finished their degrees and all, but ONGC said, yes, whatever salary they want in the market, we'll give them, but let them remain. You see, this is very interesting when we make this kind of assessments, okay? So listen, the cost comparison, see, I have done this hydrogen for different, capacities. And this was presented to ONGC because they would not believe in the beginning. How did you do it? So I have to show each and every calculation. Very interesting. So 1 kg of hydrogen. And so remember the word in energy scenario in 2050, solar, wind, hydro, nuclear, gas, some coal will be still used. We will not be getting rid of coal. It will be still used. And how much energy will require? 49,000 terawatt hours, of which 73% will come from so-called renewable. And that 25% will be hydrogen. 25% will be hydrogen. So there is a huge business in hydrogen. When Mukesh said that, he's my student, I must tell you, Mukesh said that he's going to produce less than $1, it was news. I've been saying since 2015, no news.
And he says 2030.
Yeah. And I've been, so this is how it got attention of everybody because I presented, I got patents and all. That is how the Minister of Petroleum got attention on this. Otherwise, I would be just talking nonsense, So anyway, so the petroleum refinery versus biorefinery, I have biomass, any biomass, including waste plastic, I can convert into chemicals, fuels, and all materials. Because that is, I said, this is one of the trinities, the topmost trinity is hydrogen. And see, so this is a part of one of my research papers. See from lignin what we can make. Just last Saturday, I gave a lecture in Pune to farmers. Farmers are crying that sugar is not getting money. I said, why are you only concentrating on sugar? What about the other biomass, what you have? Convert that into a biorefinery, and I tell you how many products we can make, whether it is HMF or any other things. We can make variety of this thing, and it will add value to your this thing. In fact, they are seriously considering this. Vasantdada Sugar Institute. They want to have a collaboration with me. See how many things are there. Lignin, why burn it? I said in the beginning, burning carbon as a fuel is a bad idea. Carbon as a fuel is a bad idea because it is going to, although we are talking about carbon neutral biomass and therefore, but no, that doesn't give me money. Ultimately, it is business. You will agree with me, Gauri, right? It is business. So you have to have business. How do you get this business? So I'm giving you this one example. 1 kg of crude oil gives me 32 megajoule of fuel plus 0.2 kg of chemicals. Based on that 97.4, I will give you some other calculation. But 1 kg of biomass gives only 6 megajoule of fuel or 0.8 kg of chemicals. So what is better? Okay, this is there in my paper. Okay, and so if you go ahead, so we converted that everything on the base. So 215 barrels per second is the production right now based on the crude oil. If you take only biomass and convert to fuels, it is only 10 barrels per second. And if you convert to chemicals, it is 320 barrels per second. So common sense tells that it is better to make chemicals than fuels. Business-wise, that is a better idea. Okay, so we showed this by calculation. And we are talking about methanol economy. Once you have seen, yes, you can make methanol, a variety of products can be done. So Niti Aayog has that formula, right? So we can see that all these things, then the consumer plastic as a waste. There are 7 different types which are given here. And all of them can be hydrogenated. So your single-use plastic ban, and we started it 2021, October 2nd, which is a bad idea. I'm openly telling you, we should have collected because it is a source of energy. This waste plastic is a source of energy chemicals. You depolymerize, upcycle, recycle, downcycle, do anything you want. Not the countries in Europe and including America, they have different, regulations and rules and notifications. And you know what they did in Ireland? They did this recycle plastic, and their carbon footprint went down like anything. Why are we not doing it? If we were doing it, I'm telling you, not a single plastic will be left after the meeting is over. Everybody will pick up that bottle and put it in the pocket and take home because it is giving money. Right now, it is not giving you money, therefore you are throwing it here. Nothing free is admired, including when you go to free marriages and parties, you have all sorts of food, Malaysian, Thai, and Canadian, and Italian, and whatnot. You want to test everything and throw it afterwards. Because it is, so 50% of the waste is food waste. 50% of the waste in the world generated is food waste. So we can have all sorts of things. So this is where, so ban is not the solution. That is the motto. Ban is never a solution for any. If one technology creates a problem, another technology always solves it. That is what I'm telling you as an engineer. That is the best part of it. Correct? So we should not ban. It is like, so many people are dying in railway crossing in Mumbai. Every day a dozen people die. Have you started railways? No. So you have to have safer way of, yes. So this is what it is. So for example, this is what I have shown here that, the boy comes and drops things like that. So we can have plastic recycling, okay? Through chemical recycling. Okay, so chemical processes, you see waste plastic, chemolysis, pyrolysis, gasification, all sorts of products can be made by this. And we have been working in that area. So hydrogenation, for example, PVC, PET, polyamides, rubber, everything. And these technologies are known to the refineries right now. They are using it. So you don't have to reinvent the wheel. You don't have to waste money on that, right? So your plus process, super plus process, make sulfur out of it, give to, the sulfuric acid plants and whatnot. So this is all known. And the steel production, for example, when I mentioned to you about steel, look at India. How much was produced in 2021? And say about 102.2 or 106 point something million tons. This year it will be 120. By 2030, it will be 300 million tons. And all these processes, when you use, see, for example, if I use green hydrogen, no pollution. But that if I use this, the gray hydrogen, I produce 2.3 tons of carbon dioxide per ton of steel. Okay, and that is what we are number 2 in the production in the world. Okay, in steel. So the hydrogen production technologies are there many, thermochemical, electrolytic, photolytic, all sorts of technologies are there. I won't go into the details because you have a special lecture tomorrow, am I right? So what I will tell you something else. And then you're talking about solar hydrogen. But once again, there is a carbon dioxide pool. So once you have carbon dioxide, make carbon monoxide, make methanol, make ethanol, dimethyl ether, everything, whatever I told you before, that can be done, okay? So technology maturity, steam reforming, partial oxidation, biomass gasification, alkaline electrolyzers, all these are mature and commercial technologies, okay? And so what we did, I compared my technology with published literature. Okay, you have carbon, look, steam methane reforming with carbon capture and storage. Look at the cost there on the right-hand side, right from 2.27, and it depends on the scale of operation. If you go down here, you see, in some cases, solar thermal electrolysis $5 to $10. Okay, wind electrolysis, again, $5 to $6. Mine at the end, 0.95. That was the winner. And that is what caught the attention of the world. In fact, I got an offer from Canada to have a plant there and they will try to scale it up. So this is what happens when you have a niche technology. It knows no boundaries of the nation because everybody in the world is interested in reducing pollution. Okay, so yes, we can do it. So I look at the cost of hydrogen. Electrolyzer cost $1,100 per kilowatt in 2020. They believe that it will become $220 in 2040. Right now, IOC and other guys, they are saying about $1,500. So it is not cheap. It doesn't come cheap. So we have the alternative to electrolysis, thermochemical process, copper, chlorine, iodine cycle, sulfur cycle, which I'm mentioning. And green hydrogen, they say less than $3 will be in business. Okay. And so it is very important for us because in the electrolyzer, not only the electrodes, but also the cost of electricity is the one which causes all the problems. So the future cost of hydrogen, is believed to be, where is that gone? Okay. See, including the operation and maintenance should be less than $2. And so that is the yardstick for any hydrogen producer. And you see, initially government gives subsidy because they want to bring that in. But remember, as a scientist and engineer, according to subsidy means it is your technology is inefficient, useless. When we give subsidy to many, many different sectors, that means that technology is not perfect. It is better to invest in R&D and make that technology perfect, and whatever subsidy you are giving, that is the added benefit to the economy. Suppose fertilizer is there, for example. Can we not make it at a lesser cost? That should be the incentive. Subsidy is never an incentive. Subsidy makes people, idle. Okay, so by 2030, we will have, hydrogen economy well placed across the world. Okay, across the world. Okay, that is what I'm saying. And so India should not lag behind. If you are going to have electric vehicles, in fact, I had a meeting with Honorable Nitin Gadkari. We shared a dial somewhere. He said he has a hydrogen car and he's using it. So he's a great fan of this green hydrogen. And I'm firmly believe he's a doer. He will do it. He's one of the most efficient ministers in the country. And so you see, the next thing is that I want to show you that what is going to happen. By 2050, hydrogen demand will increase by tenfold and we'll have 539 million metric tons of hydrogen being produced and will be used in all sectors. It will be used in all sectors. So now one of the problems you mentioned about the safety and security, right? Safety and security. So anyway, the next question which we should ask as scientists, can we create a zero waste society? Can the municipal solid waste dumping grounds vanish from face of earth? So reduce, reuse, recycle, recovery, landfill should be zero. So I made in the beginning, recycle engineering. That is what we should concentrate upon. And so hydrogen will have a great role in circular economy. Hydrogen will have a great role in circular economy. And to tell you the truth, okay, so what happens, in the next case is that when we see, so green economy, bioeconomy, circular economy, these terms we are knowing. I won't spend much time on that, but this slide must tell you that hydrogen economy, look at how many sectors, 2-wheelers, 3-wheelers, 4-wheelers, hydrogen, fuel cells. Because, and you are electric vehicles, short distances within the city, big trucks, vans, etc., hydrogen as a fuel, IC engine, that is the way to go about it. And so there will be many new hydrogen applications. So current ones, yes, they will continue. We will make ammonia and all those things. But society must accept it. And if society accepts that, like I must tell you, ladies and gentlemen, in the year 1910, around that time, there was a procession by ladies in New Jersey. They said X-ray should not be used. It is depriving the women of their modesty. How foolish it was. Can you live without X-ray in any hospital? Then they had, after the Second World War, they introduced this MRI. Everybody knows MRI, but actually it is NMRI, nuclear magnetic, right? So they had to drop the word nuclear so that people can accept the other technology. So there is always opposition to any technology. So hydrogen, if some stupid fellows oppose it, they good luck to them. That is going to happen because what will they say? It is dangerous. They will say that it is dangerous. So hydrogen safety issue, we have to look at it. Okay, hydrogen safety. Hydrogen is safer than any other fuel, including petrol and diesel. Okay, just 1 minute. No. But before that, I had a slide. What happened to that slide? I'm not. Okay. Green hydrogen is safer than conventional fluids. Okay. Whether it is petrol or diesel, you have so many accidents in that. Do you abandon your car? No. Hydrogen is 14 times lighter than air. And the sensor technology is advanced to such an extent that we will detect it. So there is no problem. And therefore, I quoted Swami Vivekananda. Each work has passed through 3 stages: ridicule, opposition, and then acceptance. So hydrogen economy, hydrogen will be accepted as a fuel and a feedstock. That is what I'm trying to tell you. So finally, ladies and gentlemen, the way forward is green hydrogen will be the savior of the world. Mark my word. CO2 should not be a liability, but an asset. Agricultural waste as biorefineries and blue hydrogen a source, because we can make it from agricultural waste. Okay, hydrogen economy can be elegantly intertwined with energy and environment. And Government of India therefore should give impetus to hydrogen economy, give a lot of money to research and innovation, and believe our researchers and scientists. Not everything imported is good. And remember, fellows, when they import, they don't give us the best technology because you will be their competitors. So why should they give? So you have to develop our own technology, and we will not be dependent on anybody, whether Russia or Ukraine fight or anybody fights. It is our water, our hydrogen. We don't have to depend on crude oil. So ICT OEC hydrogen technology is one such important technology which I have developed. And so I believe that to obey the whatever we committed for 2015, climate agreement, okay, Paris Agreement, it is possible only through hydrogen. And we can make it in India. So ladies and gentlemen, thank you so much for inviting me to this beautiful conference. A little longer than what.
No, it's okay. Perfectly all right. Perfectly all right. Thank you. Thank you. I'm coming to that. Thank you very much for very forcefully making your point that it is the hydrogen that is a savior, and let's hope that will become. But there's a bundle of energy sources which one has to be considered.
Of course, anything.
And then bundle of energy sources, you have to see both safety, security, cost, all other aspects, and the method of production as well as distribution, supply chain, all those are linked. But very forcefully he argued and made it a point that it is a new source of energy which is going to be more usable and likely to be used all over the world. Well, thank you very much. We can invite few questions from the persons, and first question is coming.
I am Rajan Parshle.
Yeah, I have to go. Yeah, I have time. Yeah, 6 o'clock.
Yeah, I am Rajan Parshle. I just want to point out briefly, had in one slide that technology. This is called MECC.
Yeah.
This is a strong competitor to your this thing, because I have in my paper something which is producing hydrogen at 30 rupees per kg. If you convert plastic to hydrogen plus ethylene glycol and TPA, this is there. And
You look, I'm working on that. One of my PhD students right now, which is a dual PhD with American University, we are working on that depolymerization of PET, depolymerization of rubber, and other things, other ways. So look, waste plastic is a very good source of hydrogen and chemicals in materials. Yes, it is very important. We can get hydrogen from that. There is no denial. So, but the collection has to be there. We have to have associated technology, whether it is HCl is coming out of it, or H2S is coming out of it, or ammonia is coming out of it. We require those absorption technologies. So that is going to happen. Believe me, as days go by, technologies will mature. And there is no, and we must build our own technology. Like Sony always says, we must make our own product outdated. So research and innovation has to be there continuously. You cannot remain idle. Okay, I have produced hydrogen, so let us stop there. No, nobody can afford. In fact, we are not spending enough on R&D in India. You know that, including private companies, except pharma companies. We are talking about GDP, 0.79% only are spending on R&D.
This has been patented also.
Yeah. I know. So you see, the most important part is to take to the commercial scale. That is the most important part of
Okay.
technology.
Okay. Any other question? Here some other.
Yes.
Hi. So thank you. First of all, it was an eye-opener to see thermochemical processes being converted for hydrogen conversion. But I have two quick questions. One is for electrolyzers, we know the cost is really high because of the critical raw minerals that go into it, tungsten and platinum and nickel and all of that. But there are some studies going on in India which are now looking at replacing these materials with more common minerals. Right. So have you been looking into it? That's my first question. Then the second is
Listen, in my case, I'm not looking at that, but I have one part there is in electrolysis, which is making copper back into the copper form. But we have developed alternate electrodes also to platinum.
Right.
Yeah, we have done it, and it is very efficient. That is why I could get patents. So the whole thing right now is that the complete cycle which you have developed, I don't have space in ICT, formerly UDCT in Mumbai. So I have to go somewhere else. Since ONGC was my sponsor, I requested them to give a place. So they have given me a place in Goa now. But the ministry said I should do it on a campus of a refinery so that hydrogen could be used by the refinery. Because I can't let go hydrogen in the atmosphere. I'll have to use some fuel cell to consume it or store somewhere. So these are technological advances. So yes, but it is very, very exciting. As an engineer, as a scientist, what has excited me most in all my career is this, that I'm seeing the fruits of my labor of my students, that we can do it in India.
When we talk of the electrolysis of hydrogen, water, so if we are mixing some salts, sodium bicarbonate and other thing, the cost of the efficiency of the hydrogen generation, that keeps on increasing. Is there any research on that one?
No, I've not done research because see, listen, I concentrated on this particular cycle because it was very difficult. So we got the best result after 1 year of hard work. Okay. So I did not work on that. I worked on this, wanted to make it highly energy efficient. That is why my cycle is a copper chlorine cycle. In fact, I had worked also iodine sulfur. IIT Delhi is working. BARC is working. Okay, IIP Dehradun is working. ONGC had given these projects to many. I was the only one who became successful. So I know, and I have calculated each and everything, how much it will cost.
Professor Yadav,
Yeah.
it's very interesting paper. And just one half a minute. We from the sector were looking for some practical aspect of commercialization of this. You did so much of research, it has to take a shape of a commercial conversion. Because as a country, we are struggling, the Niti Aayog, etc. So how long will it, your assessment, how long will it take for India to make any commercial venture?
Maximum 3 years. Maximum 3 years. Maximum 3 years.
So I would like
Short
to say,
question. Yes,
it
short
was a very motivating lecture, and we must say Jai Hydrogen.
Thank you. Thank you, because they have got some.
There is already one speaker, next speaker, scheduled to speak to us virtually. So we must thank him. We argue this point that brings that's going to Savior. Or now next speaker might say this technology is looking for the savior for the world. But very important thing is, which you landed, research is very essential, and people are not seeing the other side of it. It's if you do not do research, there may be right now cost of producing maybe, but flip cost of not doing is much more than the cost of producing. Even if the cost of doing certain thing is higher, one should look at what is the disaster cost of not doing so. So it is better to spend more money on
The
research.
mobile phone, when it was introduced, 1,50,000.
Yeah.
What is the cost of mobile phone today?
Yeah, so that this is where you have to really think of, there is the other side of the doing things, which is the flip side of it. And where flip side of it is the other cost of not doing the thing effectively. That's very important. Thank you very much.
Thank you so much. I must leave. You must apologize. I must apologize to you because I've got another meeting.
Thank you. So very well. Event also जाना पड़ेगा.
Thank you.
कौन में जा रहा हूँ?
Thank you. Very well. Ajay Yadav sir, thank you. Thank you. Excellent. Good. Excellent. Do we have another, we have another speaker, Dr. Ghosh, to speak to us on this?
Good afternoon. Am I audible?
Go ahead. Yes, you are audible. Go ahead, please.
Okay, thank you very much. Anyway, so already I have committed another person because earlier it was supposed to be end at 5:30, but so accordingly I told somebody that 6 o'clock I'll be meeting. But unfortunately, because I cannot reschedule that on, I don't want to reschedule. So I'll be talking hardly for 10 minutes and I'll take another 5 minutes question answer session. If it is okay, Chairman.
Because many people have to go for their other work. That's why you find a few people left, but 10-15 minutes would be ideal for your explanation and then few questions from you.
Okay, no, I initially prepared for 15 minutes plus, 30 minutes plus 15 minutes question answer. That's what you can see. I had total slide number 45. But I'll be going very fast. I'll be only touching upon few of the things. Some of the things is already being discussed by previous speakers. So some of the key points that I wanted to discuss. So that's what I'll be touching upon. So probably by 5:45, I have to finish as I have to go for another meeting. So thank you very much, Dr. Amrit Goel, for inviting me and giving me this opportunity. This is a subject which I'm actually working on from 1999. This is the core of my heart, actually. And I was struggling. I came back from Germany in 2004 with all the knowledge, and I'll be sharing some of the things. I struggled. I knocked all the ministries. Nobody cared about that. But now the time has come when I see that all the people are so much interested about this. So I'll share some of the things which I have. And sorry, I could not come physically there. I would love to come because there are lots of dignitaries with whom I wanted to actually meet personally. So I'm actually on a mission, which is one of my dream project. I'm working for Indian Army and I'm going to North Sikkim tomorrow. So I'm actually on the way. And that's the reason even I don't have good network connectivity. So that's what I'm not switching on my video as well. So this is I committed that I wanted to convert one army base at an altitude of 18,000 feet and to make it completely green based on PV. And this is the system what we have done. And it is being already commissioned into 2020, sorry, it's 2021. So this is almost 1 year and 2 months it is running there at that altitude of 18,000 feet without any interruption. And so that's one of the achievement I have, and which is also green, and this is for Indian Army at that altitude. So I thought of just sharing with you so that you know that why I could not come physically there. Now, though I had a plan for the talk outline, but it does not make any sense, so I'm just skipping that one. Of course, this one I cannot skip. So where from I come? So I'm from IIT Bombay. So this is, you know where it is lies, and this is a very fairly new department in IIT Bombay, so which started in 2006. We have different initiatives, and also we have around 25 faculties. So this I'll skip now. I don't want to make the story because already some other people they have made that. So one thing, as the Dr. Sen was talking about this particular comment, that because some of the students I found they are talking about this. Please remember one thing: when you talk about 40 years or 400 years, it doesn't make any sense when you talk about future energy crisis. Because when you're talking about fossil fuel, you should know that this is a millions of years it is being stored and it is being used in 100 years or 200 or 300 years. So when you talk is a 40 or 400 doesn't make any difference. This is all future. Even if it comes after 400 years, still we need to start from now. So that's what that particular comment, as was mentioned by Mr. Sen, that the Stone Age did not end because we ran out of stones, and the oil age will also not actually end because we will run out of oil. And then the other quote, very important quote, which was given by Jules Verne, is long back, and he actually that time told that yes, water is going to be the future for the energy resources and all other things. So that's what now we feel today, that hydrogen economy is going to take the shape and also give the shape to the nations and also to the globe. So now when you talk about the fuel transition, as we start always, that earlier biomass was there, but when industrialization started, so it started from coal, and then slowly if you see that how the fuel journey has gone through, so you can see that with time the carbon versus hydrogen ratio has come down. So ultimate goal of course is going to be hydrogen. And then now you can see that different color as previous speaker was talking about. So there could be different ways this hydrogen can be derived also, which is conventionally people are deriving, as well as now newly what we are talking about is that green hydrogen. So that's what now some of the properties I'll be removing. And that one point I wanted to mention, because previous speakers were also talking about, so I wanted to just clarify here. Sometimes we tell hydrogen is actually very much having very high specific energy. It is wrong sometimes, because how you actually, from which perspective we see it, actually depends on that. If you talk from weight point of view, it is very high, but if you go by volume point of view, it's very low. And when you go for, let's say, any places, so if you have to pay for the volume as well, because if you are making container, you have to pay for the container as well. So so hydrogen is having both the sides. Is very high. We call always that's it's having very high gravimetric energy density. It is having very low volumetric energy density. We need both of them should be very high. So and then other important point how to talk about that flammability. So generally it is very wide compared to other things. If you can see here, I'm sorry because I'm actually rushing through this slide. Even I'm not enjoying this slide, but somehow I'm trying to manage the time. So this is how hydrogen is having a wide range of the this thing. And then other problem what is being talked about, hydrogen is very dangerous. It is completely a myth. You can see here there are three different scenarios that are being shown. So as I was talking about that, hydrogen is having very low volumetric energy density. That's what is very light as otherwise. So as it is very light, it always actually reacts as the roof. So when there is accident happens, let's say somebody is in the kitchen and then there is an LPG leakage, then that when it catches fire, it catches along with the person. But if you go for hydrogen, it's otherwise. Actually, we can escape because it will be always resting at the roof, and always you can escape from the room without catching the fire. So, but some of the things what conventional energy converter does and what fuel cell based or hydrogen based economy is going to do. But when you talk about complete system, is that in this case, the main difference is that we can always avoid the combustion path, and you can directly convert chemical energy to electricity. So these are both of them are high quality energy. So you can avoid the thermodynamic cycle like Carnot cycle. Now different types of hydrogen, how it can be derived also already some of the people have already discussed. So I'm just leaving this particular slide. And this is also being discussed by different people. So I'm also skipping this, that these are different types of hydrogen, how it is being derived, like green hydrogen, blue hydrogen. There are also gray hydrogen, black hydrogen, and like this it's coming. So finally, what I want to discuss that one of the things I was working in Germany from 1999 till 2004. And one of the work was actually using hydrogen, not the way we are talking now at this point of time. At that time, we are talking that hydrogen as a complementary to the battery, because what battery can do, hydrogen cannot do. What hydrogen can do, battery cannot do. So that's how I was working for a project where we used to tell hydrogen as an energy carrier for long term in conjunction with battery as a short term in renewable energy sources. So this is what we discussed, that because why we tell long term, because there are, when you talk about renewable energy like solar, there is a particular type of trend is that we call diurnal motion. Because of that we get day and night. There is another one is the seasonality, and because of seasonality you also will be having another types of mismatch. And this increases with the latitude. So that's what, if you, in our country probably it's not that prominent, that seasonal part. So that's what I used to feel probably in our country during that time it was not that prominent, but the place I was working like Germany where it was also very important, and that's what they were working on that particular subject. Now this is a system what I am talking about. This is it's long back, if you can see now from 99 when we did this particular work. So it's a 43 kilowatt photovoltaic and then 300 kilowatt hour battery. So it's a big battery bank also you can see, and there was also PV, also hydrogen. And just to give an idea that if we go for this type of system, so I'm just removing the rest of the things. I don't want to go to. So this is what I want to talk about. So this is the data from 1997 till 2001. So you can see that directly from PV, it was going to the load for around 30%. Then next, another 50% was coming from the battery, and the rest of the things was coming from the hydrogen, and to make a completely 100% reliable system using PV, using this battery and hydrogen as a complementary energy storage device. So this is one. And so now I'll be coming with that at this point of time when you're talking about hydrogen, actually hydrogen, the role of hydrogen has changed now. It is not as a complementary to the hydrogen, it is otherwise. I'll come to that point. It looks now that battery is going to be a complementary to the hydrogen or to the electrolyzer where hydrogen we are producing. So when you're going for hydrogen, as people are discussing, so there are different technologies now people talk about. One is that let's say alkaline electrolyzer. Other one is this is the working principle. So the other one is so first one I'll talk about the PEM electrolyzer. So in PEM electrolyzer, there's the electrolyte made of Nafion, and then both the sides there are catalysts. Now I wanted to mention here that as we go for this type of electrolyzer, it requires the precious metal catalyst. I wanted to also just refer to the previous some of the comments made by the speakers that it is possible sometimes by mass production to reduce the cost, but sometimes it will not be possible if you are using a precious metal like platinum. Probably it might go in otherwise also. So I wanted to mention here in this case the PEM electrolyzer, mainly the catalysts which are being used, which are very much expensive, and that is one of the bottleneck why these are the technology is not coming in the market. The next one, and this is a characteristic of how PV looks, and what I wanted to talk about some of the things is that let's say other one is that alkaline. If you see, the main difference is that in this case you need some noble metal catalyst. In case of alkaline, you can go with a non-noble metal catalyst. That's why this type of technology is very cheap. It is well known and people has already explored, and nowadays also in our country, mostly all the companies they are going through this particular technology. But still, there are some other companies that are trying to explore that. And in IIT Bombay, I'm not talking about research we are trying to do, but just here I wanted to mention we work on both PEM and alkaline, and we are actually engaged with some of the leading company in our industry in India. So these are the costs, because ultimately whatever comes into picture and whatever is that it is novel or not, ultimately cost is the deciding factor which is going to dictate. And I'll just remove, skip all these things, technology, because it will take lots of time to discuss. Only I want to talk about three different technology. One is the PEM, another one alkaline electrolyzer, and solid oxide electrolyzer. So out of these, outermost is the most advanced, or it is matured, and inner is that actually less matured. So in this case, you can see that for alkaline electrolyzer, cost and track record, this is very matured, and rest of the things, if you see footprint, it takes lots of the space, and some of the other problems are there. On the other hand, PEM is in between, and solid oxide electrolyzer is actually in the nascent stage of this. Now, this cost is also already being discussed. This is being taken from DOE website. Sorry, I forgot to give the reference here. The one thing I want to discuss here is that the green hydrogen, what we talk about here, this is the number. You can see that in Indian rupees, it is being converted. This is the target cost around. This is target cost in the sense, don't confuse with the $1. This is the target selling cost. Is a 600 to 450 to 600 rupees per kg. And I wanted to just spend a little bit more time on this. That is it feasible or it's not feasible? As previous speaker also discussing about the cost and $1. So I want to tell you, it is not like this. What you can see here, that if you are connecting the electrolyzer at bottom, what is being shown here, and PV to wind, and then you will be producing power. This is hydrogen. This is one option. But you know that whenever you are going for the renewable resources, they're intermittent in nature. You will be having a capacity factor of 30% to, for wind, it will be 20%. That means if you are installing an electrolyzer for it and expecting 8,760 hours of a year, it will be operating. It's wrong. It is going to be operating 1/5 of that time, or sometimes it will be 1/3 of the time if you are taking photovoltaics. So, and 70% of the time it will be actually idle, or it will not be able to operate its maximum power, rated power. So that's what one of the major problem. But your investment cost is same. So that's what you need to have battery. So that's what earlier I was telling that earlier we are telling that hydrogen is actually supporting battery in case of the PV system. But now it is opposite. When you are going for hydrogen economy, actually battery is going to give support to the electrolyzer to make it operational 100%, so that the capacity factor of electrolyzer is 100%. So if you do this and if you do the calculation, so I'd like to beg to disagree with the previous speaker. It is not that right that the total cost of the electricity is that high compared to the other costs. So here I have given some I'm not sure whether you can see the top portion. I'm not able to see my top portion, but what I wanted to show here is that first part is that electrolyzer life cycle cost. I also try to do a little bit of life cycle cost, because I believe that without that, my any system will not be seeing the actual commercial life. So this is the electrolyzer life cycle cost, and per kg of hydrogen, it is actually coming to 224 rupees. But there are lots of ifs and buts. You see that total lifetime I have considered 80,000 hours, 100% capacity factor means without any failure, without any operation. So it should run for, if you see that 8,000 is that on per year, 8,760, almost 9 years, it has to run continuously. And then if you take all these things, then only you are going to get to 24 rupees. But how it will be running if you are doing with PV? It is not possible, of course. Then what is you need? You need a storage. And if you see that 30% is coming directly from PV, as I was showing in previous slide in the other context. So this 30% PV cost will be around 15 rupees per kg of hydrogen. So that's what I wanted to compare, that if you talk about the energy storage, hydrogen production cost, probably contribution of electricity cost will not be that high. But if you go for the storage, then storage is actually contributing more than the actually generation cost. You can see here. This is a number what I'm giving. Please do not, we will not be debating on this exact number, but this is a ballpark number. It can vary here and there based on the technologies. But this gives an idea that how storage is going to play a major role in hydrogen economy. If you are talking about the green hydrogen economy, I must say, when you are going to use solar, mainly solar or wind, only solar and wind along with the electrolyzer. So that's what somebody was talking about, that hybridization. So hybridization is going to be also very important. Other thing what I want to discuss now, the application. When you talk about applications, several other applications were discussed. Now, which one I would like to discuss is an electric vehicle. So in case of electric vehicle, in case of electric vehicles, then generally we try to discuss about the hydrogen and diesel and lithium-ion battery. That is the intermediate what I think about. So this you can see that there's a weight. If you see from the weight point of view and the volume point of view, for the tank I'm talking about, but if you go for battery, this is the weight and this is the volume. But if you go for similar kinds of hydrogen-based electric vehicle, so you can see this is the total weight and 125 kg compared to 650 kg, and but the volume wise actually 260 liter compared to 107 liter. So this is what you can have this type of system. So it shows that okay, hydrogen-based vehicle is going to be actually very much compared to the other battery technology. Probably it is in between diesel and lithium-ion battery, and that's what somebody was discussing about the range extender. So fuel cell is going to be mainly applicable for range extender, not for the passenger vehicle at this point of time. Probably in next 5-10 years, probably it will be very useful for the trucks and other things. The other thing what we want to discuss is that the refueling time, that is very important. So if you go for a diesel, all of us, we have an experience that we'll be having maximum 2 minutes to 3 minutes time. And if we refuel for 1 minute, so we'll be able to drive 800 kilometers. If you take the electricity and if you charge for 1 minute, we'll be able to travel for 8 kilometers with a very high supercharger. That's what I'm talking about here. And then if you go for hydrogen and do 1 minute refueling, that background calculation I'm not going there, so you can travel 100. So you can see in the order of magnitude 8 to 100 to 800 kilometers for in 1 minute. So this is another thing why fuel cell based things are going to come. What I want to discuss here is that sometimes we talk that why if it is so good, why it's not coming in the country as well as worldwide. So one of the major problem, as I think initially when we had a discussion, I think Dr. Ms. Joel was talking about the inflation and discount. This is one of the very interesting part. I also see that when you talk about platinum and other things, it's not coming because it's very expensive. But I found a different answer to that. And what happened that as they are very expensive and they are precious, so they do not take part in the reaction, so they do not degrade. As they do not degrade, if you see the total lifetime, you'll be finding that at the end of the lifetime, you'll be having the entire platinum what you have loaded, you'll be getting most of them available to you. And ultimately, so this is the catch now. If you see this and if you do some cost analysis, I'm not going in the details of the cost analysis, and I did some calculation. One with that very low loading of platinum, other one is very high loading of platinum. And this is for fuel cell I have done, but this is also true for electrolyzer. And we found very interesting case that only I'm going to show that is the how platinum cost has increased and from 2000 till 2015. And I did this inflation rate and discount rate, and then I tried to find out what is going to happen, the platinum salvage value at the end of the lifetime of the vehicle or at the end of the lifetime of the electrolyzer. So then we found that if you have, let's say, very high platinum loading, then you'll be having a total cost of 102 per kilowatt of platinum. Then out of that, you'll be having a salvage value of 41. Platinum salvage value is 61. So you'll be having a net present cost is 41. And if you go for low loading of platinum, then you will be having a salvage value only 6, and you will be having net present value of 51. And if you go for the next, let's say next scenario, after 10 years when you are replacing your fuel cell or this thing, so actually your net present cost actually becomes negative. That means what will be happening? You will be actually earning out of it instead of actually investing. So this is what is my calculation, where if you bring net present value and also the discount rate and inflation rate. Anyway, so I used to make a joke of it that okay, if you are buying a fuel cell car, so it serves both the purpose. One is that like it's a horse, you can use it for racing. At the same time, so you can use at the end of the lifetime, and also you can use it for daily purpose going to the markets. That's what it happens if you have a fuel cell. At the end of the life of your car, you can sell the fuel cell, and you might get even more than actually you can recover the entire money of your car even at the end of the lifetime of the fuel cell. So this is what I wanted to share. Of course, I had to jump a lot. Even I'm also running out of time. So hydrogen is considered as a future energy carrier. Hydrogen can be produced from different energy sources, and green hydrogen is considered as a sustainable solution. And PEM electrolyzer would be cost effective only and only if the catalyst is recycled, as the previous speaker was talking about. And if it is recycled, then this PEM electrolyzer is equally cheap. So with that, I'd like to thank you. Sorry, I had to hurry it up. But of course, we should also keep it in mind that we should not make IST as an Indian stretchable time. We have to make it an Indian standard time. Why I'm telling this? My German colleagues, sometimes when I was doing PhD, they told me that, do you know the meaning of IST? I told you it's Indian standard time. They told, no, it's for us, for you, it's Indian stretchable time. So I tried my level best to bring the time on track. Thank you very much.
Thank you very much for very effective communication of your development research, and particularly the taking it to the last point that how it's going to help the people. Well, if you have some questions, we can shoot. We have another 5 to 7 minutes because we have to close the session by 6 o'clock because the speaker is waiting for that. So you have some questions to ask Dr. Ghosh? If there are no questions, then we can thank Professor Ghosh and then move forward. Thank you, Professor Ghosh. There are no questions. We have to take a little more time to absorb whatever you have given to us very effectively. Thank you very much.
Thank you, Baba.
Thank you. Well, I think we have 5 to 7 minutes overall, and to 3 minutes of maximum 5 minutes time. As I said earlier, that it's a model of development which we started from animal sources of energy to mechanical sources of energy. We moved from the steam to electricity to then we came to fossil fuel to became biomass. Yeah, I know. In fact, it has been working in France for last 20 years, recycling and doing it all. This thing, this technology is already going on. Then solar, which became very important. Solar kilns were created and etc. Presently, some of the countries are working very seriously on solar energy. In particular, China is working on solar energy very effectively. There is one book I recently read on what is going to be 2041. combination of AI and the development in the world, as well as the energy. The last chapter is on energy. And their calculations and estimation of predictions, you might call section, that by 2040, we are going to have a solar energy almost zero marginal cost. It's going to be almost free energy available. We had a cost-based energy available to us for last several years, centuries, and now it's going to next 10 or 15 years, a zero marginal cost energy. And then your method of production distribution is also undergoing change because of AI, and now next is going to quantum computing. So your way of life, you're doing things, etc., is also changing. So that's kind of an estimation is that in course of another 10 or 15 years, the aspects of the storage of energy in terms of the solar energy is going to change much more than what we have been observing last several years. The panels, etc., which are created absorb the solar energy, also going to change much more. So its cost is going, as it is, the cost of solar energy is going down. But there is not going to be a single source of energy which is going to solve the problems of development of the human society or whatever on the planet Earth. But what is going to be very important is the two factors will remain. One is source of energy, which has been discovered, renewable and non-renewable sources. Two non-renewable sources of energy are the solar and wind, and non-renewable sources are even recycled ones are non-renewable. And that model is based on the megalopolis, metropolis, etc., where connection, wastage, etc., can take place. If you go to two-tier city, if you go to three-tier city, for certain wastage is not as much to create a process of energy generations, etc. All those problems are there. So model of development mixed with the AI, which is coming in big way, machine learning, and augmented realities, etc., where you find that now he was not required to travel here. Like that, many things will happen on there. With the new bandwidth availability through the satellite link from one end to another end of the earth, where the cable, etc., issues are also going to be solved in course of 10 years or so. People will not need the cables which you are having now, internet, etc., through satellite. Satellite, I have worked with this. And when we had EduSat launch in this, we were communicating without any wire, only receiving terminal were there, receiving both sides, receiving as well as both terminal audio video. So we could reach only difference was 4 seconds. Any part of the country which we are, any part of the world. If they are linked with the satellites throughout one or your bandwidth problem will also go. With the new technology on AI, etc., with the availability of the communication system and the energy source, there are new sources of energy which is coming in a big way. That's what there are other sources of energy will remain, which is renewable, the wind and the solar. And solar is taking much more investment in the Chinese economy and Chinese technology development process. So these all issues will be there, but it's a basic fundamental aspect would be the least carbon footprint sources of energy and a new model of development which we are taking it in course of time because of AI and other. And next 10 years you will find that quantum computing coming in a big way where all this present type of computers which you are using, calculations, etc., which will take, now new technology has come. Everybody must be finding out the crypto, etc., blockchain technology. Blockchain technology consumes a lot of energy, and there are thousands of computers. They are not single computer, and that it works. But if that calculation can be broken and can be done in this quantum computing, things are going to change. So world is going to change, not that it is, but at the same time, it's not going to happen in a day's time. It may take. So development does take place in various ways, and energy source is the key to this. When we change from human to animal source of energy to the mechanical sources of energy, now coming to solar and the renewable sources of energy, things are going to. The estimations are there. It will be almost zero cost, marginal zero cost energy, which will be freely available to people will have to find time what to do. With the AI mixed with this, it will be a not 4 days work. They are changing 5 days to 4 days. No, it may happen that not there 3 days, because many things would be happening in production distribution on their own. So these are the aspects which we take. I would like now to thank all the speakers who came and both virtually as well as physically making present. Dr. Jadhav came from Bombay and he made presentation on net zero, particularly hydrogen technology, and Dr. Ghosh and other people before. Now I close the session and thank you very much for this.
आप कुछ कहेंगे चले स्टार्ट आप कुछ बोलना चाहेंगे बिफोर आई स्टार्ट
As you wish. I'll just say a few words. Good evening to all. We are very happy that we are having this lecture today on climate resilience and urban and low carbon India, which is a very huge subject. We have been discussing in the morning to how the hydrogen is going to be the future energy system and how it is going to be looking, I mean, whether we really need to know and what are the problems in upgrading the hydrogen to that level as we are looking with the hydrogen mission and all. So when we talk of sustainability, there are three things: ecology, economy, and equity. That's what someone said. So probably that should be the goal of low carbon India, according to me, of ecology, economy, and equity. So we cannot have one like economy, or we can have one that will not suffice, or ecology only. So we have to look all the three aspects. So that is only I would like to say, because, and I again welcome you all for, and we have with us Mr. K.N. Srivastava, who is Director of IC, and he's given us this opportunity to hear Shri A.K. Jain, who is the former Commissioner of DDA, New Delhi. So he is a very, well, I can say how, I mean, he's a big expert on urban planning issues, low carbon issues, climate research, and he has written many, many books. So we are we are very fortunate to hear him today on his lecture. We hope that you enjoy, and thank you so much.
Am I audible now? Okay. At the outset, I would like to pay rich encomium to Maltese and to the Climate Change Research Institute for organizing this workshop. I am sure in the inaugural session and the technical session, the subjects which have been discussed, each one of you must have really enjoyed and must have been benefited with that. In this session, we are going to have a talk by Sri A.K. Jain on climate resilient and low carbon India. Friends, I hail from Eastern UP. Just before coming over here with a cup of tea, when I was discussing with my friends, I mentioned to them that I never imagined that in our lifetime itself, so much of climate change will take place. I recall my young days, student days, and now what I see, the tremendous amount of change has taken place. In Eastern UP and adjoining Bihar, I have experienced myself that during the rainy season, that is the area which grows paddy on a massive scale. So I remember, for irrigating the paddy crop, the farmers would be simply digging a well in their farm, just 4 or 5 feet below the water will be there, irrigate the paddy crop, and then close the whole thing. Today, when I go to my native place, I find that the water table has gone many 100 feet down. And so much so that that area which was abundant with water has now started facing water crisis. Even the quality of water, I find that it is totally different. In our childhood, we used to drink water from the well without any kind of hesitation. But today it is just not possible. Traveling train, from north to south. After getting into IAS, I was allotted Karnataka cadre. So in those days, we used to travel by those long distance trains. We simply, used to fetch water in our surahi at the railway stations and drink that water without any hesitation. There was no problem at all. But today we can't think of. So all these kind of things have happened. In the coastal area where I had the opportunity of serving, the soil erosion with the sea wave. Earlier, people were not so much conscious. Today, you can see from your naked eyes that actually it has started happening. Villages after villages are getting completely washed away. They're getting engulfed by the sea. I had opportunity of working as a Secretary Civil Aviation in Government of India. That was my last assignment before I retired from the service. That was the time when this Kedarnath tragedy took place. I remember I was part of that crisis management group. My job was to arrange all kinds of helicopters and air services to help the Maroon people, the people who were in distress. What all was happening and why it happened, those things are really something which made me to take stock of what is happening, on the climate front. The heat waves of 2015 and 16, the extreme flooding in Kerala that has taken place in 2018-19, they're all eye-openers. The devastation caused by super cyclone Amphan in Sundarban areas, the landslides which are becoming so rampant in Uttarakhand and other parts of the hilly part of India, they're all warning signals. Now, unfortunately, the kind of seriousness which the world community should show towards the climate change is, I would say, still missing. No doubt, efforts have been made. Kyoto, that agreement was a really very positive step forward. But whatever was gained in Kyoto has been lost in Paris. Nations are still not ready to work together, and we are all suffering on account of that. Now, I would not like to say much before I request Sri A.K. Jain to deliver his talk. I would only say that wherever we are, we should develop this consciousness, and whatever we can do as an individual, as a community, as a nation, we must give our might to that and do to save this planet and prevent carbon emission as much as we can. In IIC, we have done a little bit, though it's a very small, step forward. We recently, some 3 years back, we put this solar power plant. I'm very happy to inform you that now, on an average, 300 units of power we are generating over there on average. Nowadays, of course, generation has gone to almost 370, 375 units. Roughly about 15% of our total power consumption of IIC is now going to is being met from this renewable source. In addition to that, the kitchen waste that we generate every day, that is going for biogas generation, and that is again being used in the kitchen. So these small things at our level also have done. We have also tried to ensure that no kind of discharge of any kind from IIC should take place outside. So all the water we are recycling, and recycled water is being used for garden, other purposes, etc. The slurry coming out of biogas plants is being used as fertilizer. Earlier, we were very heavily dependent on drawing underground water to meet our IIC requirements. We roughly consume about 1 lakh of liters of water per day, and almost 75,000, 80,000 liters we used to draw from the underground. Now it has been brought down considerably. It is now only some 25 to 30,000 liters. And we are working on a plan to see that in the next 3 to 4 months' time, our draw of water from the underground comes to complete, not zero. So with these few words, let me first introduce Mr. A.K. Jain before inviting him to deliver his talk. Though he's a very familiar face, I don't have to really introduce him, but he's a customary, which I must do that. Sri Jain has worked as Commissioner of Planning in the Delhi Development Authority, and he was also a member of the Committee of Ministry of Urban Development on DDA in 2015. He was a member of UN Habitat in 2007-2012. A member of editorial board of International Journal of Environmental Studies UK. Mr. Jain has authored several books, including Tall Buildings and Vertical Urbanism, Discovery and Publishing House, New Delhi. He was awarded 2nd Urban Professional Award 2014 at World Urban Forum in Medellin, Colombia, and IBC Lifetime Achievement Award 2016. Now, ladies and gentlemen, I invite Mr. Jain to kindly deliver his talk on this famous topic or important topic of climate resilient India, climate resilient and low carbon India. Mr. Jan, please, the floor is yours.
Thank you, sir. First slide. Start with the first slide. Thank you. I am really grateful to Ken Srivastava, Director IIC, for giving me this opportunity. First slide is Mekan. Giving me this opportunity to talk to all of you and also celebrate the World Environment Day, which we had on 5th of September. And I think IIC is the perfect venue because the IIC building by itself is one of the greenest and the earliest green building without talking about green building concept, etc. Done in 60 years back. And the director IIC has already explained that they are continuing with the tradition, with the heritage of this as one of the most green building with least urban footprint, recycling of the water and things like that. So basically we had all this COVID and we were all indoors. So this cartoon I made while sitting at home, that it is feeling was like Bhisham on the bed of arrows, and the bed of arrows is climate change, COVID-19, then the air pollution issues, the traffic jams, energy crisis, loss of jobs, especially for the informal sector, and all these kind of things. So this was the situation we were all facing. So World Environment Day 2022, the theme is only one Earth, and we have to live sustainability in harmony with nature. This is the broad theme of the United Nations for this World Environment Day. And as Dr. Malti Goyal has just now said that they are working on the workshop, they are conducting a workshop on awareness and capacity building in hydrogen production and energy uses, which I'm grateful they have accepted this presentation of mine as part of their proceedings. We have already heard the Director IIC, and this is the most favorite building for most of the architects, perhaps for everyone, and perhaps the best building which was built 60 years back. And this is, we used to call it building in the garden. And this, when Frank Lloyd Wright was building organic buildings in the USA, this was some example that we can also create this kind of organic architecture. And in spite of 60 years, the whole style, the architecture, the sustainability remains impeccable even after such a long time. And as you have already heard from the Director IIC, they have gone for rainwater harvesting, solar energy, wastewater recycling, thermal insulation, energy saving, SCADA, and also using solar energy for heating of the water. So this is something which we can learn, and this is something which they have created a very good example for us, and this is the ideal venue for this kind of talk. Now, what is happening is that because of the limited jobs in the rural area, the people are migrating to the urban areas, cities like Delhi for jobs, and the urban population, which was 377 million, 37 crores in 2011, is projected to be 600 million in 2031. That means after 10 years or 9 years. And this is the situation of the city bus, that we are having all the problems of traffic, congestion, pollution, etc. So this is something which this cartoon says. Okay. So this is some aliens who are eyeing to come to Earth, the planet Earth, and when they see the situation of the pollution and the kind of air, they say that We should forget about coming to the earth, and the earth people will wrongly believe that we want to take over their planet. It's not worth taking. So this is a famous flying carpet, and the young couple is going in the air for celebrating their honeymoon. And why they are going in the air? Because they think that at the ground there is so much of congestion, so much of flies, so much of pollution. But even in the atmosphere up in the air, they find a lot of flies and all these kind of things. When it won't be a picnic without without flies, without mosquitoes, etc. So we are caught in a vicious cycle of climate change, and because of the heat which we are experiencing too much in these days, this is basically is emanating because of more built up area, more heavy footprint on the earth, and the transport, energy, buildings are being produced, are being consumed in a much higher proportions than the capacity. And this means more urban expansion, more carbon and greenhouse gas emissions, and this causes climate change. And everyone knows when we are using air conditioning, it generates all this hot air which gets into the atmosphere. So the rising urban heat is now a reality, and there are scientific studies how these heat islands are being created, and we all are experiencing this. And this heat island is basically created because of the concretization, because of the paving of the roads, because of the loss of greenery, because of the materials without proper insulation or proper absorption of the so this is something which is already happening, and many cities are preparing the heat mitigation plans. For example, Ahmedabad has recently done a heat mitigation plan where they are putting up very, I think, simple methods. For example, making the roof whitewashing the roof, or putting white paint so that the solar heat is not absorbed, but it is reflected back into the atmosphere. So when we are talking about the carbon emissions and greenhouse gas emissions, the maximum comes from the energy supply, which is about 26%, industry 19%, transport 18%, buildings 10%, and waste 3%. Others may be 24%, others may be infrastructure services, etc. And it was projected by the IPCC in way back in 2010 that the global warming may be 2.3 to 4.8 degrees due to the projected doubling of the carbon emissions. And every country, including this Paris Agreement, resolved and agreed to restrict the warming to 1.5 degrees Celsius maximum. And action plans have been prepared by various countries. And when we talk about the transport, which contributes 18% of the carbon emissions and 70% of the particulate matter, this is a cartoon which shows that keep smoking, double bypass ahead. So this has a double meaning that we are spoiling our health and heart, and this may lead to this kind of heart disease. So we are having a kind of alternative fuels. In the 70s and 80s, diesel was very popular because it was cheaper than the petrol. In 2000, around 2000, the Supreme Court ordered that CNG should be used in a big way, and all public transportation should be run on CNG, and CNG came, and now other kind of fuels are coming, including electric batteries, etc. So this is where we are at a crossroads. So this is also having a lot of negative impacts. For example, the poor transporters, three-wheelers, etc., who are running informal transport, they don't have even fitness certificate. They are suffering the most because of these kind of things. We all know that about 40% of our cities, including Delhi, are unplanned, are having slums, And it means they are having very deficient infrastructure services in terms of very deficient energy, perhaps no water, poor drainage or no drainage, no sanitation, and waste management and transport are almost missing. And unfortunately, the municipal corporations and the government bodies don't take care of these things because they said that these are not notified municipal areas. So this is kind of a problem we are always facing. And the traffic, everyone knows when we go in Delhi, in spite of so many flyovers, in spite of metro and everything, the roads are always choked. And traffic is increasing 3 to 4 times the population growth. Population growth of Delhi is growing, is increasing by 2 to 2.5%, but the vehicles are growing at about 7.5% per annum. And we have more than 1 crore 10 lakh vehicles in Delhi which are running every day. So this is a major problem, not the population. Then we are facing a lot of urban challenges like the slums, transportation, urban services, shortage of energy and sustainability, heat island, all these urban challenges, and the human beings are just diminished just here, and everyone is a builder oriented and public-private partnership oriented approach. So everyone wants to get the maximum FAR, maximum advantage of the space or the land, and they are putting so much of footprint without bothering for green spaces, etc. So this is at least I got a permanent job because I have to fill all the potholes in this stretch of road. So these potholes, I don't know why they are not being cured. And if you open the TV even today, you will find Bangalore, etc. Potholes continue in spite of all the media attention, politicians' attention, nothing is happening. So what are the gaps? We are having a lot of gaps. We think that urban is separate from rural, development is not sustainable. There are delays in the projects, and we are always talking about speed and technology. Then gender and equity is there is a gap between the gender, and then the planning. We do a lot of planning, but implementation is almost neglected. So we are working in silos, and we have to dismantle these silos and understand that ecology is a topic which is interdependent, interrelated, and interconnected. So, and the biggest silo which we are having is our own mindset. We have to break this mindset, then the things will open up. Otherwise, we will keep on giving excuse. Finance nahi the, ya administration nahi tha, ya legal framework acha nahi tha. These are all superfluous things. But I think the biggest problem is our own mindset. So we have to think about the city in a very different manner. City is not something where you put inputs and get output. It's not an industry. It is a much more than that. Sustainable development means it has to have a circular metabolism, circular system, and it has to be eco-city. So whenever we are planning, we have to think what will happen to the output if smoke or pollution is coming out of factories, etc. How these things can be taken care of or recycled or minimized. This is the more important than the inputs. So this is circular metabolism. Then what are the parameters of a sustainable and livable city? These have been defined by the Ministry of Urban Affairs, our own ministry. That physical 45%, physical means mobility, water, wastewater, solid waste, etc. Economic will have 5%, and social 25%, institutional 25%. Institutional means organizational setup, etc. So this is very, I think, logical in the sense that physical is the root cause of these sustainability issues. So if we are not able to take the physical, there were a lot of pressure from the economist when this was being worked out, that economy has to be very strong, all these kind of things. But they have put economic only 5%. So physical is at the root of sustainability. This we have to understand. So the UN Habitat, the UN SDG always say that leave no one behind. This is almost a slogan. That means we have to think about localization. We have to provide access to the infrastructure, the facilities, the energy, jobs, etc., to everyone, and leave no place behind. Visibility. Yeah, yeah. No, it's not possible here. Yeah. Anyway, I think if anyone needs, I can send the presentation by email. Okay.
Lights can be put up here.
So basically, we have to rethink the process of urban planning. What we have been doing, the urban sprawl, American model, developing suburbs, developing all these unending townships, etc. Perhaps we have to go for urban form and save land, forests, greens, and reduce emissions. This is the fundamental. And this is a chart which I have taken from IPCC report. And IPCC report of 2014, sixth IPCC report, identifies 4 issues: density, land use, connectivity, and accessibility. That what should be our pattern of development so that we put minimum footprint on the ground and we reduce emissions and we don't damage the forest, the greenery, etc. So this is something which we have to understand, and we have to give up this greed of acquiring land and putting more and more. Perhaps the better strategy is to redevelop, redensify the existing urban areas. That is much better than going into the greenfield development. So optimum use of land also requires we have to go for mixed land use in place of single land using, which we borrowed from Britain. And we were very fond of this kind of single land use planning, zoning in 70s and 80s. We have to go for mixed land use, and we have to understand interdependence of these various land uses. And if the industries are not polluting, zero polluting industry, which have become a mandate under the Environment Act of India, I don't think there is anything wrong if industries, residences, commercial activities all coexist. So this chart is basically analysis that rather than having segregated urban structures, like we have colonies in Delhi, Jorbagh or Golflinga Defense Colony, where everything is independent, we should go for more composite development. Composite development means we make a block where the surface area is minimized and the site area can be reduced from 100 to 34% by composite development. Envelope area, which absorbs heat, will be reduced by about 1/3. Heating energy will reduce to 68%, and construction cost will also reduce by 58%. So this is something which we have to understand, and I've been writing to the Ministry of Urban Affairs when they are regularizing these unauthorized colonies that go for composite development. Promote that 8 to 10 families come together and build up a multi-story housing development other than isolated buildings. So that can be a more sustainable model. With COVID pandemic, public health has become a very central issue, very core issue in urban planning. And when we are talking about health, we have to start with the people, the lifestyle, community, local economy, and built environment and global ecosystems, how they are all interrelated and should focus on the human health. That should be the core of the whole thing. So whenever we are planning our infrastructure services, we have to relate with the health system, what kind of health facilities, whether the health facilities are locally available, and all these things should be taken on board. And this is what work and life integration by mixed land use. So if something is not damaging for the urban environment, so housing and community facilities like nursery school, primary school, or maybe small work centers or shops, etc., can all coexist within a composite residential development. Building materials pyramid. This is something like food pyramid. At the top is the most damaging building materials like aluminum, copper, maybe something. At the bottom are the materials which are most eco-friendly, like recycled building materials, recycled steel or timber or bricks, and in the center are steel and concrete, which are very popularly used, and we can't avoid those things. So when we are designing a building and taking construction, we have to consider that we make maximum use of the materials which are sustainable, which are at the bottom of the pyramid, and minimize the use of the materials like glass, aluminum, non-ferrous metals, etc., which are sophisticated as much as possible. So those should be minimized. So air has become a very major issue in urban development, and as urban planners, we can't say that it's not our concern. This is very much concerned with the urban development, urban planning, and we have to go for policy of zero polluting energy, biofuels, green hydrogen, renewables. We have to have intelligent pollution management. Pollution management is being done, but unfortunately, it is not real time. It is not intelligent, and a lot of information is always missing. Then we have to conserve transport by 15-minute principle, which has been recently adopted in Paris. That if you want to walk to the work, it should be about 1 kilometer, residence and work, and cycling 3 to 4 kilometers. If you are using public transport like bus or metro, it should be 10 kilometers. So this should be the necessary parameter and principle of urban planning, so that people don't have to travel, and they use the cycles, they use the non-motorized transport, which are non-polluting to the extent it is possible. Buildings can also be redesigned as respirational systems, urban nebulizers, detox towers. Buildings, when we first create buildings, and then we try to give some kind of medicinal treatment, how they can be less polluting. But by design itself, they can be detox towers. And we have to minimize need for air conditioning by passive design and green roof, ventilation, landscape, low energy building materials, etc. Watershed development, we have been listening, we have been doing this watershed development since maybe 1850s. And I remember the watershed development plans were prepared for not only for cities, but for the entire sub-regions and regions. And for example, in Roorkee, we find that all this watershed development was the basic principle of development of rural areas as well as urban areas. Locational decisions were taken so that the natural water channels were not disturbed. And the scale or the basic unit of planning used to be basin, not just riverfront. Now we are very fond of talking about the riverfront development, landscape development, but basin of a river with streams and how the water comes, how it falls, how it recharges the groundwater has always been our strength, which we on the way perhaps we have lost this thing. We have to think of common utility ducts, that means low carbon zones with tri-generation energy systems combining power, cooling and heating, dual piping, low flow appliances and water saving toilets with recycled wastewater system, wastewater recycling with dual piping system, micro irrigation system, vertical forms. These are some of the tips which I think are very important for sustainable development when we are talking about infrastructure. And clean water, the government is committed to provide clean water to every family, and Jal Jeevan Mission is aiming to provide 24/7 potable water, rainwater harvesting, recycling of water, dual plumbing, efficient fixtures, and also invoking new technology like blockchain, SCADA, LIDAR, etc., which are, I think, very important, and we cannot keep them different from the planning system. And I am happy that IIC has already adopted this kind of SCADA and LIDAR, maybe blockchain, but they don't use the word blockchain, which are, I think, very important. Everything is in computer, and on a mobile phone, you can control where the water is leaking, where the waste is getting collected or not getting recycled. So this is something which we have to think of. Then we have a lot of dirty drains in our cities, and this is a drain which used to be in Oshodham in Pune, and this has been converted to green trail. So this, in Delhi, we have got about 600-kilometer long drains, which are dirty, corridors of filth, unhygiene, illness, dead bodies of the animals, etc., which can be beautified like this. And this is not something foreign. I think everyone can do it. We are also thinking of urban agriculture. The government of Delhi has already worked out some plans for urban agriculture so that the transportation of agriculture produce, vegetables and fruits is not required or minimized. And we have this urban agriculture within the urban areas. And this is a project which was done in Seattle. And they have used these containers, old containers, retrofitted them, and every container is providing space for agriculture. And this is also a mixed land use development. Apart from this, the farmers who are doing this are living within this area, within these apartments in the at the lower floors. And this is also saving 90% of the water for agriculture, because this is all based on micro irrigation system. And in this process, this also cleans the air and also recycles the wastewater by bioremediation. Sustainable transport, as we have seen there, this is something, a big culprit in carbon emissions and fossil fuels. And this can be improved by rethinking and discouraging the private ownership and the private flying of the vehicles. And 50 cars can be replaced by one tram or bus if we plan properly, and if the tram and bus is not deficient to the travel in the car. That means it's air conditioned, it is dignified, it is timely, it is punctual. So these are things which are already being adopted. Zero emission green hydrogen. This is the bus. I took a picture, I think, in USA, maybe about 10 years back. But this is also coming to India. And the National Hydrogen Mission, which has been announced by Prime Minister in this Glasgow conference, has committed that 4 metric ton of green hydrogen per year will be produced in India by 2030. This is a fuel which will replace even the batteries to a great extent. And then we are talking about the multimodal hierarchy, and at the top, the pedestrians, we have to improve the walking facilities, the footpaths, etc. We have to promote public transit system at the second level. Third, we have to promote non-motorized transport like bicycle or even rickshaw. And fourth is the pickup and drop of taxis or autos. And the last in the hierarchy comes the private vehicles, which should be relegated at the last. So walkable urban structure means that the distance between the metro station or the railway station or a bus station and your residence or workplace should be maximum 400 to 500 meters. That means 4 minutes to 5 minutes walk. And this is the kind of pattern which has been developed for some new localities like Dwarka, so that people can walk, need not to take car every time they go for shopping or dropping off the children to the school. Transit-oriented development means we have to make optimal use of the land, and we have to conserve private transport to the extent possible. And transit-oriented development means that at the transit stations, we use the area and the land, the buildings to the optimum level, and maybe go for high-rise, high FAR. And skeleton parking parking has become a very, very big issue. So skeleton parking can be given at every metro station or railway station or bus stop, which is, I think, being planned, but it's not getting implemented. This is the problem. So we have to see that how it can be implemented. And if you see this picture, the green strip and the pedestrian walkway is also has been integrated with this multi-level parking place. Transit-oriented components, there are at least 10 components which we have to, when we talk about the transit-oriented development, like interconnected street network, non-motorized transport network, informal sector integration, and last mile connectivity. These are the things which I think we don't have to go into the details. We have to consider, and we consider in our transit-oriented development. Intelligent smart pole, which gives basic information about the temperature, about the climate, about the rainfall, and things like that. Even the pollution, and also it has CCTV. This has already been, this is being implemented in certain localities. Even in IIC on Max Muller Road, there is one smart pole put up by NDMC. So this also gives some information if you press a button about the maybe route chart, things like that. So this is something which we have to press for, and it will save a lot of energy, a lot of give real-time information about the pollution, about the transport, about when the bus is coming, all these kind of things. Energy efficient building is also very important, that we minimize the use of the energy, and we can save. We have tried this kind of system. 30% of the energy can be saved by energy efficient design. That means we provide some insulation, we provide some kind of solar panels, we provide facilities for solar cooking, with recycling of water, etc. So these are very important, but these are very practical also. Wind turbines, solar parabolic and microgrids can be combined in building design, which is still at least in India at academic level, at the books level, but we can try this thing, and in isolation these have also been tried here and there, but this require a more sustained effort. Then intelligent, integrated and interconnected infrastructure is related with the whole concept of recycling, reuse, minimizing the use of the natural resources. And this chart shows that how the earth comprising of sky, air, fire, water, and the infrastructure services work in an integrated fashion. And recycling and reuse, all these are the ingredients of this intelligent, interconnected infrastructure. Smart and sustainable infrastructure services means that now in this fourth industrial revolution, everything is on computer. We have to use all these infrastructure services in an intelligent manner with the latest technology, which is already available in India. We are not backdrop, but unfortunately, our municipal bodies are not aware of these things, and they continue with this kind of traditional systems without invoking the modern technology. Waste-wise city has 5 strategies of reducing the waste, refuse, reuse, recycle, and recover. And in this hierarchy, the bottom at the bottom is the disposal. That means landfill. This disposal should be minimized. And I've been pleading that in every residential locality, we have to have kind of recycling facilities, that we have a recycling center where you can, and these are vanishing. In fact, in traditional housing, we always had these kabadis, and who will buy old papers, old cloths, and recycle it, repair it. So this kind of culture is missing. As a result, our waste generation has multiplied to about 1 kg in daily, 1 kg per capita per day, whereas it used to be only 0.3, 1/3, about 10 years back. So solid waste management, smart waste management means that everything has to be computerized, everything has to be on mobile network, and how the waste is being collected, managed, recycled can be done by computer process. This is an SOPAM. And blockchain technology for integration, decentralization, and synergy. This is a new technology, which is, I think, is very much in India, but this is being used for business transactions, etc. But I think this is something which in urban development, urban planning, and architecture, this can be very useful. Then 7 C's of sustainable built environment include there has to be circular systems, there has to be climate resilience, clean air, water, energy, and transport. Then there has to be health, conservation of culture, and natural environment. And how we develop this thing into this is my own sketch of what can be the city. And most of the public transportation is underground, so that the ground level is kept for children, for people to interact. So basically, we have to complete this complicated issues together, and we have to complete the jigsaw by proper development, coordination, planning. And this means that we have to, when we are talking about sustainable development, the 5 P's of this sustainable development include people, planet, partnership, peace, and prosperity. And this is a figure which I borrowed from UN system on this sustainable development. And there are 5 elements, but only one earth. And the 5 elements are Akash, air, fire, water, earth. And everything is interconnected, interlocked. So, and at the base of everything is Sattva, Rajas, and Tamas. So we have to create this kind of integrated system in our development. So there has to be continuity between plans and implementation. Sometimes we hear that we are very good in planning, but very poor in implementation. And this is the kind of thing which happen and which we always face. And this is a cartoon which I prepared when I was in the DDA. So this is a mission of life, lifestyle for environment, mindful shift towards minimalist living. And this is the last slide. Thank you very much.
Thank you, Mr. Jain, for a very excellent presentation. Let me take some questions.
Yes.
So Mr. Jain is will be very pleased to answer some questions. So let us devote about 10 minutes on question answer. But before I throw the floor open for question answering, just 2 observations. He laid a lot of stress on this urban transportation and the issues arise, pollution issue arising out of that. See, I had a long stint in the Bangalore Metro. At that time, I was studying the footfalls at Delhi Metro and New York Metro. Today, if you look at the population, Delhi, the extended Delhi, I'm saying, the population is more than New York. But if you look at the footfalls, in New York, the footfall in those days, even now also it must be same level or even more, used to be more than 1 crore per day. Whereas Delhi was somewhere struggling between 10 lakhs to 15 lakhs to 20 lakhs. Even now also, I don't think it has gone more than 25 lakhs per day. The reason why it is happening is that, in our metro, we have this platform to platform typical railway approach. That you come to this platform, I'll transport you to another platform. But how you reach this platform, it is not my botheration. And how from the other platform you reach to your destination, it is not my botheration. So unless there is a complete planning, for a person to start from his house and reach his workplace and come back, the urban transportation will always be under, question mark. So there is a need for, complete planning of urban transportation, and there comes the role of multimodal transportation system, feeder systems, and things like that. The other observation I'd like to mention here is that a very typical problem arose in city of Jamshedpur, where the Tisco's plant is there, the steel plant. See, the slurry which was coming out of the furnace, the waste which was getting dumped, and a sort of hillock was created. So once we started getting cooler and cooler, settling down, then the small particles started flying into the air, and it became a massive kind of air pollution problem. So much so that the Jharkhand High Court has to issue notice to TISCO that if you do not control it, we are going to order closure of the TISCO steel plant itself. So real panic was created all over, and these people searched for the consultants. I would so finally the Indian consultant who had got experience of working outside, he came with a solution. And today, if you go over there, that whole slurry hillock has been converted into a beautiful touristic place with a lot of greenery all around, etc. What all he has done, I'm not going to bore you with those details, but that gives us an idea to us as to what can be done in the Gazipur line, that whole hill that we have created. Solutions are available. There are technical people. It is only up to the people who are managing the governments, who are at the helm of the administration. It is up to them to get hold of the right kind of people and get all these problems sorted out. So with these remarks, I now throw the floor, open the floor for question answering. Yes, sir. Please identify yourself and ask the question. Just identify yourself. How mic use कर लीजिए. हाँ. अपना नाम बता करके then you can just start. Okay. Right.
I am paid that in front of the office CTO complex, there are so many government officials, ministers and others come there, and I can show you a photographer having 5 buckets full of used glasses. Used glasses, persons come there, they drink juice from the vendor, and there are 5 buckets and 2 tokeries full of used glasses. So this is generation of waste. We talk about waste management, but there was one slide in which it was written that reduce waste means we have to control the generation of the waste.
Correct.
Instead of focusing the management of the waste. So this all goes to landfills where it catches fire, smoke comes, the people living in the vicinity, their life becomes hell, and others living apart or passing by it, they have also health complications.
So what is your question, sir?
My question is that every year World Climate Day is celebrated, we can say held, but the condition is not improving, it is deteriorating. As you said that in your village, the water level has come down up to 100 feet level, but in newspapers, there is no guideline how people can save water. What is the judicious use of water? So instead of improvement, there is deterioration. You have also expressed concern that it will lead to multiple problems. It is reducing life also. So why is this waste disposable is not banned? मतलब इतना ज्यादा ये एक दिन में इकट्ठा हो रहा है इतना, तो एक महीने में कितना इकट्ठा हो जाएगा, कितना पूरा होगा, कितना जलेगा? मेरा कहने का मतलब ये डिस्पोजेबल्स जो है, आप देखो भंडारा होता है तो वहां पे इतना प्लेट जूठा ये इतने सारे भर जाते हैं और कोई भी उस पर ध्यान नहीं दे रहा है वेस्ट जनरेशन पे. तो इसका थोड़ा सोल्यूशन.
The point you have made is very valid, that we have to focus more on implementation, and the ideas can be very good, but unless they are implemented, they don't work.
Who will implement it?
But the implementation, I think we have to look a little in a broader perspective, that a lot of things are happening. Even in Delhi, there are waste recycling which is being done. The mistakes which were committed 20 years, 30 years back, that whole thing was put up in the landfills. There is a very serious thinking that this landfill is not at all suitable for urban development, and this should be totally stopped. And we have to recycle 70 to 80% of the waste, and this is being done at several places now, even in Delhi. So recycling, reuse, etc. are coming, but it also requires a cultural change among the people. People have also to think that how the city can be cleaned, because if we leave everything to the municipal corporation or the government, it's not going to work. People have to be involved, have to be engaged, have to be awarded for these kind of things. And something is happening. So I'm not really hopeless that this thing is getting so bad. But I think with the passage of time, things are improving.
Yes, sir.
Yeah, my name is GB Bagai. You see, living in Delhi, isn't it ironic that we are living in the worst polluted capital in the whole world, and we talk about green energy, and the center talks all over the world about how we are working towards beating almost everyone in terms of achieving our targets. That is one comment. As far as climate change goes, in Missouri also now people are buying fans because it's become so warm over there. Number three I have is that, there's excellent work being done on developing roads and infrastructure all over India. But you take Uttarakhand, for instance, there's so many landslides and, glaciers are falling. So is there a sort of a understanding over there that it has to be done in a very careful manner? The Chinese are building infrastructure in Ladakh, and we are also building infrastructure to defend us. But where is it leading? Is it going to make the Himalayas, which are so vulnerable, it's going to make things much worse? So your comments.
Basically, I think there is no dispute when you are saying that the things are getting deteriorated. But I will remind you that what our Prime Minister Narendra Modi said at this Glasgow conference in November last year was very important, and he gave a concept of Panchamrit, and that means five strategy of five targets, five objectives of environmental improvement, and these talk about the new strategy for dealing with this climate change, for dealing with these issues, and they talk about the recycling of the garbage, the involvement of the new technology, including computerization in our works, and accountability, things like that, which are, I think, very important. And it takes a little time because India is a vast country, and we have to change not only the technology, but also the culture of the people. So if we see garbage is being thrown on the streets, the things are improving and the things are changing, but we have to participate and we have to work shoulder to shoulder with the government.
I totally agree with you that Delhi, particularly in the winter months, the Delhi climate is a real cause of concern for all of us who are residing in Delhi, or even for the country as a whole, because all the embassies are here, and they are now rating Delhi at a much lower. See, the diplomats, they have rated the world city in terms of their places of choice for posting. So Delhi's ranking is going down. Earlier one was given an impression that this parali burning in the neighborhood is one of the major source, but the data have now proved that that is very tiny part of the problem. The main problem, most of the problems are arising from within the city, and transportation. Sorry. Punjab, Haryana, Punjab, and these villages, the farmers are burning the stubble burning, called parali. So, but that is not so much serious. That is no doubt contributing for a limited period, but contribution to pollution is much smaller. The main problems are arising from within Delhi city, and transportation is one of them. So, as Mr. Jain was saying, besides administration, besides municipal corporation, the citizens also have to, made responsible for, are aware of their responsibility in this direction, and together only we can, really achieve some success. Yes, sir.
Simple things. What will it take to enforce rainwater harvesting in Delhi? The law has been there. but it is not a serious implementation. That is one point. Second is 6 years back, we touted smart cities, allotted smart cities on basis of lot of, evaluation. Has any proper smart city, single one come about? The third point is, when you talk of improving city lives and you are afraid of migration to cities, a lot of value can be generated by TOD. But is there something in the law or in the planning that what TOD will happen in Delhi, at least if we know by example? Thank you. Yes, I think Mr. Viz has been engineer chief and also member railway board. Yeah, member railway board, very experienced. Whatever he says, I think has a lot of weight behind it. So I have nothing to contradict. But the problem is that we are talking about rainwater harvesting. It is perhaps the whole thing is a little faulty because buildings in a city cover hardly 10 to 15% of the area. We are focusing on buildings, not on the roads, not on the open spaces or the parks. So unless we start, which are covering about 70% of the area, we start with this thing, which are the responsibility of the government agencies, mostly government agency or the local authorities. It's not going to make much difference when water harvesting. And smart cities, I think this is going a little slow, little backward, what we were envisaging. And it has been, I think, more of a domain, struggle for domain. For example, according to the 73rd and 74th Constitutional Amendment Act, urban development is a local subject, state within the domain of the state government or the local body. But when the center is giving some kind of program with incentives, financial incentives, it is not mandatory for states to follow it. So it is being done in a half-hearted manner that the states should have taken much more initiative for these smart cities and things like that, urban development, which has not happened. And there is, as you know, there is a struggle who will control the MCDs. And even in Delhi government is fighting, the central government is fighting. So this is kind of thing which we have to correct, which we have to do. And whenever we are talking about smart cities or TOD, I think the more strong is that it should come from the grassroots. That means we have to strengthen the local authorities, local bodies, the planning agencies, and then only the things will work out. Otherwise, I would supplement with one more statement. Yes. Jawaharlal Nehru Urban Renewal Mission from 2000, some 4 or 5 to 12, with 120,000 crore rupees, and nothing emerged out of it. What emerged? Nothing. We haven't learned lessons at all. Yeah, I think we have to.
Just to supplement what Mr. Jain has said, only two things I would like to mention here. One is that when you were in service, I was in service, Jansa was in service. We never heard of governments publicizing themselves. Only when there used to be some foundation laying or inauguration of a particular completed project, there will be some advertisement appearing. But now a new trend has developed, all over. I'm not mentioning X, Y government, all over, self-publicizing. Now, the flip side of self-publicizing is that the accountability is getting lost. See, in our time, you were mentioning about this rainwater harvesting or why it is not being enforced. Somebody has to be made accountable, and the system is already well laid as who is responsible for enforcing it. But if whether the person has performed his duties or not, he is not being held accountable at all, because the moment a group of officials are held accountable, then the governments feel that it is a reflection of the government, so therefore it should be put under the carpet. So this publicizing is causing a lot of damage to the public administration itself. This is my personal view. And I entirely agree with you. There are several things, which together, government, administration, public together, must really take a serious note of the, dangerous situation which is before us. And together only we can tackle it. Nobody can claim that single-handedly or by doing X, Y, Z, it can be done. It is a collective problem and it has to be solved collectively only. Yes, sir.
My name is Sudhir Dev. I have a few questions. See this.
Mic on.
Yeah. Yeah, it's working now. So one of the things is smart city. I personally believe that it's not entirely a failure. But what have been the key learnings or success or key failures since it has been implemented? What can be, as a correction? So what are the key points which you think needs course correction and some of the successes which can be, paced better?
I think this is a very important question, and this has been questioned even in the parliament, that urban development under the 73rd and 74th Constitutional Amendment Act is the mandate of the state government. And of course, the local body, which is also part of the state government. And the smart cities, the whole program which has been developed was a central government proposal. And how they try to mobilize the state government by giving certain amounts, certain assistance, financial assistance. And it has worked somewhere, it has not worked somewhere. For example, in the states where there was not the BJP government, like Tamil Nadu or in Maharashtra, these things could not take off. There was always friction whether we should assist the state government, whether it will catch votes for the central party or for the local party or the state party. So this has a mixed experience of success and failures. But I think the very important thing is in the case of smart cities is that the concept is not wrong. Concept is beautiful, and we have to move in the 21st century with all algorithms, blockchain, new technology, new systems. We have to move, but it should come from the grassroots. We have to strengthen our urban local bodies which are dealing with the grassroots, and we have to tackle these problems in a more holistic manner, in a more comprehensive manner. And the friction between the local body, the state government and the central government should be minimized, or should, wherever there are difference of governance patterns. For example, in Delhi, we have the AAP government in the state, we have at the central level, we have the BJP, again at the municipal level, we have the BJP, and there's a lot of friction which happens here. So we have to rise above this political system and make our administrative system so clear and so well planned that the politics does not come in the issues of development, in the issues of human justice. Thank you.
See what Mr. Jain has said. That will be a very ideal kind of thing, that everybody becomes very conscious and becomes cooperative. But there is basic flaw in our administrative structure itself. You see, if you go to any developed country, they have got a concept of city government. The New York mayor is all in all. Everything is under the municipal corporation. Similarly, any developed country you go, you find the similar kind of thing. And whereas if you come back to India, the mayor is a non-entity in any city of India. Hardly anything. My city is Bangalore. For managing Bangalore, there are 50 agencies. Bombay, everywhere, Delhi, he has just mentioned, we have created all kinds of interests which are really conflicting with each other. And now we have to really take you from the successful model available in the world, implement it here. Then you will find there will be perfect coordination, everything will go properly, and this conflict which you are seeing day to day will get eliminated. But we have to have the political will. It is very difficult. I mean, what I'm saying is not going to be accepted by anyone. No chief minister of Karnataka would like to give Bangalore city into the hands of a mayor, because his whole authority comes from the same as Bombay. Here also, why do you need a municipal corporation, then controlled by the central government, then another state government? Just one entity is required. That's all. Give all authority to that entity. This is a larger debate, but ultimately we have this is where the solution lies. Yes, sir.
One more statement.
Yes, sir.
You see, for TOD or for improving cities, a lot of redevelopment should take place in a city. But see the tragedy of Delhi. About 30,000 hectares of land around the city. The land pooling scheme was announced about 10 years back. It has not got implemented. The planning is not getting completed by DDA and perhaps MCD. Why that is so in the national capital?
Yeah, that's true. That's true. There are several examples available, sir. I think we are already getting late. Just in 2 minutes, I'll give you an example of Hiroshima city. Hiroshima, I don't know anyone of you went to Hiroshima or not. See, when the atom bomb was dropped, half of the city got completely destroyed. There is a hill which separates the two parts of the city. The radiation could not travel in the other part, so the other part remained intact. I visited in '93. That time, they had brought out a concept of land redevelopmental scheme. So the old city, which was not affected, they were having the same or walled city kind of, not much of facilities. So they brought out this land redevelopment scheme under which, area-wise, they were demolishing the old structures, constructing, modern infrastructure, etc. Transit facility was created for the people to go and stay over there till this is done. And then they were given concessional finance for reconstructed houses. And the whole city has been redone and beautifully. And several other countries have, started, following that one. So that kind of, broad thinking of land pooling, see, it's all part of this kind of exercise. So for that, we really need determination. We have not been really showing that. Just some flip-flop here and there we have been doing. Any other question? Yes, sir.
My name is and I'm an architect by profession. So the first observation I have is that we talk about urban planning in terms of cities, but the situation we have in India now is that it's all shaping out as one extended urban mass. You cannot distinguish it. You would have distinguished between Noida, is that fine, sir? Is that audible? Noida, New Delhi, and Gurgaon. But you look at it now in the MPD 2021, you reduce I'm saying you because I would imagine you were associated with that. You reduce the green belt to the width of one urban village, one village. Earlier, it was a very distinctive green belt, which was done away with, and for reasons of population. Effectively, that translates into the fact that between Delhi and Gurgaon, it can be one continuous urban sprawl with a symbolic gesture of a green belt being one village wide. So if you drive from Noida, Greater Noida, or Noida Extension, all the way to Manesar, it is one urban sprawl. There's nothing like this anywhere in the world or in the history of mankind, this manner of extended development. All these years, we have been looking at the West for answers. The West developed the metro systems in the late 19th century onwards. We started developing it in the late 20th century. Those answers will not suffice for the kind of population pressure we have, sir. So we have to imagine our own answers to the situations that befall us. How are we going to do that? Because as an architect, I come to a project, to a situation, one stage after you do. You plan the stage, we try to go and implement it. And I am extremely worried about what is going to be the urban issues that are going to confront us. We don't have the imagination and we don't have the answers. To drive from New Delhi to Gurgaon, we go on the Jaipur road. I'm just going to spell out real life examples. So an alternative route was developed as the Dwarka Expressway, which has been in the planning and in stages of implementation for the last 15 years. It's not complete, and they have promised it will be ready by December 2022. I don't see it happening. But you have allowed TOD on either side of the Dwarka Expressway because the metro line is going there. The levels of density, wherever the TOD is implemented, will encompass that route entirely. So this will not be an alternative road to Jaipur. How do we answer these questions, sir? I mean, I'm talking at a theoretical level. I'm asking you. I'm not asking for specific answers to the examples which I've spoken about, but the problems which will confront us over the next decade or two. Do we have answers for it at all?
I think you have raised very pertinent issues, no doubt about it. And what we inherited was colonial system of planning. And we model our town planning act according to British Town Planning Act of 1948. And we used to be very fond of preparing 20-year master plans, which never work. The projections never were not found very correct, these kind of things. So what I've been professing now is that we don't require master plans for 20 years. We should have master plan, whatever you call it, because master plan is a legal term under the Delhi Development Act. Master plan should be only for 5 years, where we can foresee, where we can think. The second issue which you have raised is also, again, I entirely agree. We should do away with this greenfield development altogether and freeze the whole greenfield development for at least next 10 years. And we have tremendous potential to redevelop, redensify the existing urban areas. So this can be a better answer than going for greenfield acquisition of land pooling. These are not the proper answers in the Indian context. And these are also very damaging from climate change perspective. So the paper which I had sent to the IIC and director asked me to make a presentation exactly says these things which I said, but for the paucity of time, we have not gone into detail. But the point, the brief point I'm making is that we have to introspect what we are doing, why we are doing, and whether these are in tune with our Indian ethos, Indian culture, our heritage. Thank you.
So I think we should come to an end. So friends, I think we have devoted considerable amount of time to discuss this subject, and we are all very thankful to Mr. Jain for delivering a very wonderful talk and very informative. Now, whatever are the takeaways from today's deliberations, let us try to implement wherever we are. So with these words, once again, let us give a big clap to Mr. Jain for his talk. And my kudos
give
to...
the vote of thanks.
Yes, please.
Thank you. As has been pointed out, that climate change is the most critical threat the humanity is facing, making 21st century catastrophic. And it is said that about 70% of the land and about 40% of the ocean area is already gone beyond our control. So under these situations, I think future generations are at stake. And I'm very thankful to Srivastava ji pointing out how the change is getting accelerated. We are seeing it that when we talk of climate change, we thought it is uncertainty, and now we say it is a certainty, as in the latest report of IPCC, that is 6th report, which has come out only in April. So we are really, IIC has been under his guidance, taking a lot of sustainability measures, and they are commendable. So we thank you, sir, for taking out this discussion forward for the planning of cities rather, because it is the cities which consume about 70 to 80% energies of the total consumption which we have. Maybe it is less for India, but we are talking of the general average term globally. And they are the major contributions of the greenhouse gas emissions, which is contributing to global warming and climate change. So talking about the sustainability, this Paris Agreement, which he talked about, Shri Jain Sahab, on 2015, also took a decision, the world took a decision of sustainable development goals, which are expected to give by 2030 world happiness and peace, which there in 17 goals have really defined the various characters of development for sustainability of the world. And Shri Jan has pointed out how how he has integrated in his lecture various goals like SDG 7, which deals about the energy conservation, energy efficiency, SDG 10 about the consumption, sustainable consumption, and the SDG 11 about the cities planning and sustainability, and then 13 climate action. So he has integrated, focused on integration of many of the SDGs and many more, these in addition to this. So we have to think in those terms, and relating to, he has been able to bring out a plan for the future sustainable cities, which can bring down the climate, carbon emission footprints, and also the sustainability. So with these remarks, I thank him for an excellent lecture on this topic, covering all aspects of city planning, from the transport to the buildings and everything. And I thank you, sir, for these deliberations.
Thank you.
And we thank you, IIC, for the
very good questions. And of course, the Director IIC and Director Dr. Chandra, who have made me to, gave me this opportunity to talk to all of you. Thank you very much.
Thank you very much.